Beyond Pluto, in a region called the Kuiper Belt, there are many small and distant objects. For decades, Pluto marked the boundary of our planetary system. Now, that view is being reconsidered. The James Webb Space Telescope has provided evidence of a new planet beyond Pluto, a discovery that could change how we define and understand the outer region of the solar system. But how many more planets remain undetected beyond Pluto's orbit? Before we delve into the James Webb discoveries, we would appreciate it if you could like the video and comment below where in the world you're watching from and what time it is for you now. We're always excited about reading where our viewers are watching from. Our solar system is full of activity. Along with the 8 known planets, there are asteroids, comets, and moons, and more of these are being discovered every year. For a long time, astronomers have been searching for a 9th planet, often called Planet X. Finding it would be a big deal because it could help explain how the solar system is shaped and how it works. The James Webb Space Telescope has recently added a new layer to our understanding of the solar system. For most of us, the traditional picture of the solar system has always included Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. These were the planets we memorized in school, the foundation of our early lessons in astronomy. If we also count Ceres, which orbits between Mars and Jupiter in the asteroid belt, then every major planetary body orbiting the Sun inside Neptune's path is accounted for. But Pluto's position in this list changed more than a decade ago when it was officially reclassified as a dwarf planet. That reclassification happened partly because astronomers found another distant world that seemed planet-like, forcing them to rethink how we define a planet in the first place. In the early 2000s, 2 astronomers from the California Institute of Technology presented evidence that pointed to the possible existence of another hidden planet, often called Planet X. Their research came from studying the strange orbits of distant objects beyond Neptune, known as trans-Neptunian objects. These include icy, rocky bodies and dwarf planets such as Pluto, Sedna, Haumea, and Eris. The unusual clustering of their orbits suggested that something massive, still unseen, might be tugging on them from far away. Astronomers have always wrestled with mysteries about how stars and planets form. One puzzle is that most stars are found in pairs or groups, yet our Sun stands alone without a twin. In earlier centuries, before the invention of powerful telescopes, people believed that only 6 planets existed: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. This belief held until the late 18th century, when new discoveries began to expand our knowledge. In the year 1781, the famous astronomer Sir William Herschel discovered Uranus. At first, this icy blue world was mistaken for a star and then thought to be a comet before its true identity was confirmed. Uranus orbits the Sun at an average distance of about 1.8 billion miles, roughly 18 times farther than Earth. Its distance varies. At its closest, Uranus is about 1.6 billion miles from the Sun, and at its farthest nearly 1.98 billion miles away. 1 year on Uranus, the time it takes to complete an orbit around the Sun, lasts 84 Earth years. Another leap in knowledge came with the discovery of Neptune. Herschel nearly found it himself, but Neptune was officially identified on the night of September 23, 1846, by 3 astronomers who used mathematics to predict its location. They had noticed irregularities in Uranus's orbit that hinted at another planet's gravitational pull. Neptune was far too faint to be seen with the naked eye, but with a telescope it revealed itself. Soon after, astronomers discovered a moon orbiting Neptune, though it took more than a century before a second one was found. Our understanding of Neptune grew dramatically when the Voyager 2 spacecraft flew by in 1989, uncovering 5 new moons and confirming that Neptune is surrounded by dark rings. Despite these breakthroughs, there remained unexplained orbital patterns in the Kuiper Belt, the vast icy region beyond Neptune. The fact that some objects in this region still appeared to be moving in clustered ways, even after Neptune's discovery, fueled the idea that another giant planet might exist in the distant reaches of the solar system. This hypothetical world is often referred to as Planet 9, though it has also been called Nibiru or Tichy in various discussions. If it exists, Planet 9 would orbit extremely far away in the Kuiper Belt, far beyond Pluto, in a path so stretched out and elongated that a single trip around the Sun could take anywhere between 7,400 years and 18,500 years. By contrast, Earth completes an orbit in 1 year, and Pluto takes about 248 years. Since Pluto was discovered in 1930, it has not yet completed a full orbit around the Sun. Among the known dwarf planets, Eris is especially important. When it was discovered, Eris turned out to be more massive than Pluto, which challenged Pluto's status as the 9th planet. Eris is located about 96 astronomical units from the Sun, which means more than 9 billion miles away, almost 3 times farther than Pluto. 1 astronomical unit is the distance between Earth and the Sun, so Eris's position shows just how vast the solar system truly is. Eris travels in a very eccentric orbit, swinging in as close as 37 astronomical units from the Sun, similar to Pluto, but stretching as far out as 97 astronomical units. A year on Eris, meaning 1 complete orbit, lasts about 557 Earth years, creating extremely long seasons. Reaching Eris with a spacecraft would be incredibly difficult. Because of its distance, an orbiter would need so much fuel and time that it would take millennia to complete the trip. That is why a flyby mission, similar to the New Horizons spacecraft that briefly visited Pluto in 2015, is considered the only realistic option. But Eris is 3 times farther than Pluto, making even that type of mission an enormous challenge. Despite the distance, Eris is large and bright enough to stand out against the dark of space. Its land area is greater than the entire country of Russia and almost the size of South America, larger than all of Europe combined. On its surface, gravity would be stronger than Pluto's, so a person or object would weigh slightly more there. Its brightness suggests a highly reflective, icy surface, possibly gleaming white. Eris also has a small moon called Dysnomia, which orbits it in much the same way that Charon orbits Pluto, although Dysnomia is smaller and less well studied. Beyond Eris, speculation about hidden planets has often blended with mythology and conspiracy theories. One of the most famous is Nibiru, a supposed planet that writer Zecharia Sitchin described in his 1976 book The 12th Planet. He claimed it orbited the Sun once every 3,600 years. Later, in the early 2000s, a self-proclaimed psychic named Nancy Leader spread the idea that Nibiru would collide with Earth, first predicting it would happen in 2003, and then shifting the date to 2012 to align with the Mayan calendar's long count cycle. Neither event occurred. A similar case happened in 2011, when a real comet named Elenin was mistaken by some for Planet X, but it eventually broke apart after passing close to the Sun instead of hitting Earth. Despite these myths and misinterpretations, the possibility of a real, undiscovered large planet far beyond Neptune remains a serious scientific question. In recent years, evidence supporting Planet 9 has grown stronger, especially from the observed clustering of trans-Neptunian objects. Astronomers such as Chad Trujillo, Mike Brown, Konstantin Batygin, and Scott Shepard have all contributed important research in this field. Teams at NASA and Caltech have used mathematics to argue that such a planet could indeed exist. A Neptune-sized object on a stretched, distant orbit, hidden far beyond Pluto, still waiting to be found. In the year 2020, researchers from Harvard University put forward a bold new idea in the astrophysical journal Letters. They suggested that our Sun may once have had a partner star, a binary companion, and that this lost twin could help explain the mysterious origins of Planet 9 and the Oort cloud. The Oort cloud is believed to be a gigantic, nearly spherical shell of icy material that surrounds the Sun, the planets, and even the Kuiper Belt. Scientists think it contains billions, or perhaps even trillions, of frozen leftovers from the early days of the solar system. Many long-period comets, which take thousands or even millions of years to complete their orbits, are thought to come from this distant region. The Oort cloud is unimaginably far away. Its inner edge may lie between 2,000 and 5,000 astronomical units from the Sun, while its outer boundary could extend to as far as 100,000 astronomical units. For comparison, Pluto orbits the Sun at a distance of about 30 to 50 astronomical units. According to this Harvard theory, the Oort cloud may not have formed only from the scattering of material by planets, as is usually thought. Instead, it could have taken shape through the influence of a binary companion to the Sun. Dr. Avi Loeb, the Frank B. Baird Jr., professor of science at Harvard, and Amir Siraj, then an undergraduate student, explained that binary star systems are much more effective at capturing stray material than single stars. If this is correct, then the Sun may once have had a companion star of similar mass, which was later lost when the Sun moved out of its original birth cluster. A birth cluster is a group of stars that form together from the same dense cloud of gas and dust. The usual explanation is that the Oort cloud formed from the remains of the solar system and its neighbouring stars, with some objects flung outward by the giant planets and others traded between stars. But the binary companion model offers a more complete answer. It helps solve a puzzle that astronomers have faced for decades. Most stars like the Sun are born with a binary partner, but older models struggled to match this fact with the observed population of distant icy objects. This theory also connects to the mysterious planet 9. Past models could not fully explain how such a planet far beyond Neptune might have formed, but a binary sun could make its existence more likely. Some scientists have gone even further, suggesting that Planet 9 may not be a planet at all but something far stranger. Physicists Jacob Schultz and James Unwin have proposed that it could actually be an ancient black hole, one that formed in the earliest moments after the Big Bang. Theoretical work by Stephen Hawking and others has suggested that such primordial black holes might exist. They could range in size from as large as 100,000 times the mass of the Sun to as small as an atom. Schultz and Unwin even hypothesized that if Planet 9 is such a black hole, it might be no larger than a bowling ball, which would explain why telescopes have failed to detect it directly. Another possibility is that Planet 9 could be a rogue planet, a world that was once part of another star system, but drifted away and eventually entered our own. We already know that such wanderers exist. For example, in recent years, astronomers have observed two extrasolar visitors, the cigar-shaped object Oumuamua in the year 2017 and the Borisov comet in the year 2019. It is thought that there may be trillions of these drifting planets scattered across the Milky Way galaxy. Some of these ideas have even fueled popular myths, such as the story of Nibiru, a supposed hidden world destined to bring about catastrophe, though astronomers have shown no evidence for such claims. Meanwhile, scientists at the University of Arizona's Lunar and Planetary Laboratory have proposed another explanation. They suggest that the Kuiper Belt itself, the region beyond Neptune filled with thousands of icy asteroids, comets and dwarf planets, may be hiding a massive object. This hidden body could be somewhere between the size of Earth and Mars. Its gravitational influence might be disturbing the orbits of frozen Kuiper Belt objects, causing them to tilt in unusual ways. In January of the year 2016, another group of astronomers suggested that a ninth planet, about 10 times the mass of Earth, could be orbiting the Sun at a distance roughly 25 times farther than Pluto. If confirmed, this discovery would make it the 10th recognised planet in the solar system. Professor Renu Malhotra from the Planetary Sciences Department at Arizona's Lunar and Planetary Laboratory explained their findings with a helpful comparison. She noted that the Kuiper Belt objects behave like spinning tops. If you give many spinning tops a small push, they will end up pointing in different directions, but overall they still respond to the pull of a nearby field. In the same way, the tilted orbits of these distant icy bodies suggest that a hidden mass is shaping their paths with its gravity. These different theories, from a lost stellar twin of the Sun, to a rogue planet, to a black hole the size of a bowling ball, show just how mysterious the far reaches of our solar system remain. Each proposal challenges our ideas of how the solar system formed and what might still be hiding in the dark beyond Neptune. In the far reaches of the outer solar system, scientists have put forward the idea of a mysterious world often called Planet 9. According to this hypothesis, the hidden planet could be orbiting at an incredible distance of about 500 to 700 astronomical units away from Earth. To give perspective, 1 astronomical unit is the distance between Earth and the Sun, so Planet 9 would be hundreds of times farther than that. Researchers also believe that if this planet truly exists, it might be a giant, carrying a mass nearly 10 times greater than that of Earth. Yet, despite its size, most experts argue that a world placed so far away would not have enough gravitational pull to strongly affect the orbits of the smaller objects currently being studied in the outer solar system. For an object to leave a clear and powerful mark on these orbital patterns, it would need to lie much closer, within roughly 100 astronomical units of the Sun. In the year 2015, the Kepler Space Telescope, which had already spent many years scanning the heavens and searching for distant worlds, began what scientists called its K2 mission, often referred to as the Second Light mission. This stage of its work was different from its earlier years. The telescope had suffered some mechanical failures with its orientation system, and But instead of being shut down completely, clever engineers and astronomers found new ways to use the remaining equipment. They designed the K2 program to continue gathering valuable data, though in a somewhat different style than before. During this time, Kepler once again began to peer into the vastness of space, carefully monitoring stars and looking for small dips in their brightness. These tiny dips, when measured precisely, can reveal the presence of planets that pass in front of their host stars. By this method, Kepler continued to make discoveries that reshaped humanity's understanding of the universe. Over the course of the K2 mission, the telescope identified more than 1,200 planets orbiting distant stars. Each discovery added a piece to the growing picture of how common planets are in the cosmos. Among this large group, however, there was one world that stood out. This planet showed unusual characteristics that immediately drew the attention of researchers. Scientists saw in its data a possible hint of habitability, something that has always been one of the most exciting prospects in astronomy. The planet was given the name K218b, or more simply, K218b. It was determined to be almost 2.5 times larger than Earth and nearly 9 times heavier, placing it in the category of what astronomers call a super-Earth, or mini-Neptune depending on its composition. Its mass and size suggested that it could either be a rocky world with a thick atmosphere or a smaller gas-covered planet. What made it even more intriguing was its position in relation to its star. From the earliest measurements, scientists began to think that it might lie within the so-called habitable zone, the region around a star where conditions could allow liquid water to exist on the surface of a planet. Liquid water is considered one of the key requirements for life as we know it. 2 years later, in the year 2017, another space observatory became involved in the investigation of this unusual world. The Spitzer Space Telescope, which operated in the infrared spectrum, joined the research effort. Spitzer's instruments were able to provide additional confirmation about K218b's orbital position. The data showed that the planet was indeed located within the habitable zone of its red dwarf star. This meant that under the right conditions, water could remain in a liquid state on or near its surface. The confirmation was a crucial step, since being in the habitable zone is often considered the first requirement for considering a planet as potentially suitable for life. Almost at the same time, scientists working in Chile, at an observatory equipped with the high-accuracy radial velocity planet searcher, better known as HARPS, were able to carry out highly precise measurements of the planet's density. The HARPS instrument is one of the most sensitive spectrographs in the world and has been used in countless discoveries of exoplanets. By studying the slight wobbles in the star's motion caused by the gravitational pull of K218b, HARPS gave astronomers important clues about the planet's mass and composition. The analysis suggested that the planet's density was consistent with the possibility of an ocean beneath its atmosphere. This finding raised the level of interest dramatically. An ocean-bearing planet within the habitable zone was already enough to make scientists take notice. Combined with its size and weight, the possibility that K218b could sustain water in liquid form became very difficult to ignore. The evidence continued to accumulate. Step by step, the story of K218b became more compelling. In the year 2019, the Hubble Space Telescope was used to make new observations. Hubble, with its advanced instruments capable of analysing the atmospheres of distant planets, detected something extraordinary in the case of K218b. Water vapour was identified in its atmosphere. The detection of water vapour was a major turning point because it meant that the atmosphere contained one of the most essential ingredients for life. The discovery suggested that not only could liquid water exist, but that the planet may also have a significant water cycle. The possibility of a deep ocean, protected by a substantial atmosphere, became much more realistic. For many in the scientific community, what once might have sounded like pure speculation began to take on the weight of genuine evidence. Hopes of finding a life-supporting world outside our solar system started to feel more tangible than ever before. The story did not end there. In the year 2023, the most advanced and powerful telescope ever launched by humanity joined the search. The James Webb Space Telescope, which had begun its science operations after years of planning and delays, turned its instruments toward K218b. Webb's sensors are far more powerful than those of its predecessors, allowing it to analyse exoplanet atmospheres with an unprecedented level of detail. When the results were processed, scientists were confronted with something shocking. the telescope detected traces of a chemical compound known as dimethyl sulfide, often shortened to DMS. On Earth, this compound has a very particular origin. With very few exceptions, it is produced almost entirely by living organisms, especially by tiny marine microbes such as phytoplankton. Phytoplankton, when they live and die in the oceans, release DMS as part of their natural biological processes. The discovery of this compound on another planet was therefore highly provocative. If the data were correct, then this could represent the first sign of extraterrestrial life ever found. Still, the scientists remained cautious. Extraordinary claims require extraordinary evidence, and while the detection of dimethyl sulfide was thrilling, there was always the possibility of error. The measurement came from a single instrument aboard the James Webb Space Telescope, specifically its near-infrared camera. Distinguishing between DMS and other gases such as methane in that wavelength range is very difficult. There was a very real chance that the detection might be a misinterpretation of the data or an artifact of the instrument itself. Therefore, the scientific community asked a crucial question. Could this be a glitch, a problem in the way the instrument worked, or a confusion in the signal analysis? The only way to know for sure was to attempt the observation again using a different method and a different instrument. NASA and the international teams working with Webb quickly decided to conduct repeated observations. They planned for the telescope to use a different camera that worked in another part of the spectrum. If the same compound were detected twice, using two completely different instruments, the probability of it being a mistake would drop dramatically. The decision marked one of the most highly anticipated tests in the history of astronomy. Scientists knew that if they could verify the presence of dimethyl sulfide again, the implications would be profound. On the 17th day of April in the year 2025, the James Webb Space Telescope was directed once again at K2-18b. This time, instead of using the near-infrared camera, the telescope employed a mid-infrared instrument. This allowed scientists to examine the atmosphere of the planet in a different wavelength range. The results were nothing short of staggering. Once again, the unmistakable chemical signatures of dimethyl sulfide were found. This time, however, there was more detail. The concentration of the compound was revealed to be immense, perhaps 1,000 times higher than what is normally found on Earth. Such a result demanded immediate attention. Dimethyl sulfide is not just any random gas. On Earth, it plays a very special role. The gas is produced in the oceans when microscopic algae such as phytoplankton decompose. As these tiny organisms break down, dimethyl sulfide is released. The compound has a tendency to evaporate easily and rise into the atmosphere. People who have walked along the seashore during windy weather may have smelled the distinct ocean scent that it produces. That familiar smell of the sea is largely caused by DMS, but the importance of the gas goes far beyond its odour. Scientifically, dimethyl sulfide is known for being unstable in the atmosphere. It survives only for a short period of time, often just a few days, before it is broken down by sunlight and oxygen. Because of this, it cannot simply remain in the atmosphere on its own for long. It has to be replenished continuously. On Earth, this constant replenishment is directly linked to the presence of life, as marine microbes and algae produce it all the time in vast quantities. The discovery of such an enormous concentration of dimethyl sulfide in the atmosphere of K2-18b therefore astonished the scientific world. A concentration 1,000 times greater than on Earth was not something that could easily be explained away. If the gas disappears quickly, then its presence at such a high level suggests an equally powerful source continually producing it. On Earth, that source is biological. The logical conclusion was difficult to avoid. If dimethyl sulfide truly existed in such abundance on K2-18b, then there might very well be living organisms on that planet, and on a very large scale. Such a discovery represented not just the possibility of life, but perhaps the presence of oceans teeming with microscopic creatures producing the gas, much as they do on our own planet. Detecting a gas from a distance of 124 light-years away may sound like something taken straight from a work of science fiction, yet this is exactly what the James Webb Space Telescope has managed to achieve through an extraordinary method. Each time the planet known as K2-18b passes in front of its parent star, part of the star's light travels through the thin layer of atmosphere surrounding the planet. Although only a tiny fraction of the starlight is altered in this way, that fraction contains a remarkable amount of information. The planet's atmosphere acts like a filter, blocking or absorbing certain wavelengths of light depending on which gases are present. These subtle changes in the spectrum of light are like hidden clues left behind by the planet itself, and the telescope is sensitive enough to catch them and send the data back to Earth. Astronomers then gather these clues, carefully study them, and use them to reconstruct the chemical makeup of the atmosphere. In simpler terms, it is almost as if humanity has learned to read the atmosphere of a distant world by examining the way its star's light is modified. To truly understand what K218b might hide beneath its skies, one has to first look at the conditions in which the planet exists. This world circles around a star named K218, which is a relatively small and cool red dwarf. This star is located 124 light-years away from Earth. The orbit of the planet lies very close to this red dwarf, about 2.5 times closer than the orbit of Mercury is to the Sun. Yet because the star itself is far smaller, cooler, and dimmer than our Sun, the balance of heat and light reaching the planet works out in a way that is not entirely different from what Earth receives. This delicate cosmic arrangement makes the planet particularly interesting, since it means the surface could, in principle, support conditions that are not entirely hostile to life. Because of these circumstances, scientists have classified K218b as what is called a Hycean planet. This is a type of exoplanet that was proposed in the year 2021. A Hycean world is imagined to be a planet entirely covered by a deep global ocean, hidden beneath a thick atmosphere rich in hydrogen. Observations of K218b have also shown the absence of ammonia in its skies, which fits the theory that an immense ocean may indeed lie below. Ammonia, if present, would dissolve in such an ocean rather than remain in the atmosphere. This strengthens the possibility of a water-rich world. However, the picture is far from simple. There are also reasons for doubt. If the planet really is covered by a global ocean, then the immense pressure and high temperatures caused by its thick atmosphere might make that ocean far too hot for life as we know it. Instead of being a calm blue sea, it could be more like a boiling cauldron, with conditions far beyond what even the most resilient organisms on Earth could endure. Temperature, pressure, and chemistry together might combine to create a world hostile to life. The very nature of the planet is also debated. Some researchers believe that K218b might not be an ocean world at all. Dr. Nicholas Vaughan from NASA's Ames Research Center has suggested that it could actually be a miniature version of a gas giant, something like a small Neptune, without any solid surface where life could exist. If that is the case, then the dream of life thriving there would likely disappear. On the other hand, optimism is strong among other scientists. The lead researcher on the project, Professor Niku Madhusudan, of the Institute of Astronomy at the University of Cambridge, holds a much brighter view. It was his team that reported finding traces of a substance called dimethyl sulfide in the atmosphere of K218b. On Earth, this particular compound is known to be produced by living organisms, especially by certain types of marine plankton. For this reason, Professor Madhusudan believes the planet might indeed have a vast ocean and could even support life. He is convinced that within 1 to 2 years, scientists will be able to determine with complete certainty whether the dimethyl sulfide is really present and whether it comes from biological activity or from some other process not related to life. At present, researchers estimate the probability of finding signs of life-related activity in the atmosphere of K218b at an astonishing 99.7%. In the field of astronomy, this is one of the highest levels of reliability ever achieved when looking for so-called biosignatures or chemical traces of life beyond Earth. To explain this in scientific terms, such a level of confidence is referred to as 3 sigma out of 5, which corresponds to a certainty of about 99.7%. By comparison, when the first observations of possible biological activity were made, they had only 1 sigma of confidence, which means about 68% certainty. But scientists demand far stronger proof before declaring a discovery that would change history. In physics and astronomy, the standard for something to be accepted as truly reliable is 5 sigma, which means a probability of 99.9994%, or only 1 chance in a million that the result is wrong. This very same level of certainty was required in the year 2012 for the official confirmation of the discovery of the Higgs boson particle. The same demanding standard is now expected in the case of K218b. This is why researchers at the University of Cambridge, despite their excitement, are proceeding with extreme caution. Before they can claim that life truly exists on K218b, they must first confirm with near-perfect accuracy that dimethyl sulfide is present in the planet's atmosphere. After that, they must show that the gas has a biological origin. And is not produced by some unknown chemical reaction. If both of these conditions are proven, then humanity would be facing something unprecedented, the first solid proof of life beyond our planet. The potential discovery becomes even more astonishing when one considers the location of K218b. It is not in some unreachable corner of the cosmos, but rather 124 light-years away, which is about 730 trillion miles. For humans, that is unimaginably far. Even sending astronauts to Mars, which is only a few tens of millions of miles away, remains one of the greatest challenges of our time. Interstellar travel, the ability to send people or probes across light years, might remain forever out of our reach. Yet when measured against the scale of the universe itself, 124 light years is almost nothing. The entire observable universe spans about 93 billion light years, so a planet at such a distance from us is practically in our own cosmic neighbourhood. If life is discovered on K218b, the implication would be breathtaking. It would mean that life is not some rare and fragile accident confined only to Earth. Instead, it could exist in many other places waiting to be discovered. The realization that life has been found only a short distance away, in cosmic terms, could transform our understanding of the universe. For now, all of this remains a possibility rather than a certainty. The studies continue, and the researchers remain careful not to make claims before the evidence is unshakable. Yet one thing is undeniable. Never in the history of humanity have we come this close to answering the most profound question of all. Are we alone in the universe? While scientists continue their search for clear answers, it is fascinating to pause for a moment and let our imagination travel far ahead of present discoveries, to a possible future where the mysterious world known as K218b truly harbours life. To dream about what kind of living things might exist there, one must begin with the most basic foundations of life. On our own planet Earth, the first spark of biology did not begin with large or complex animals, but with tiny microscopic organisms that were invisible to the naked eye. These humble beginnings eventually gave rise to every form of life we see today, from plants and insects to birds, mammals, and human beings themselves. For this reason, it seems natural to believe that if K218b does shelter life, it might have started in exactly the same way, with organisms so small they could be compared to the microbes and bacteria that thrive on Earth. The most likely first inhabitants of such a distant world could be extremely tough microbes, capable of surviving in a thick atmosphere dominated by hydrogen gas. Unlike the mild, gentle surface of Earth, the environment of K218b is expected to include very high pressure and very high temperatures, conditions that would crush or cook ordinary organisms from our planet. Yet this does not necessarily make life impossible. On Earth, we know of strange microorganisms called extremophiles that manage to flourish in conditions that once seemed utterly uninhabitable. For example, in the dark depths of Earth's oceans, far below the reach of sunlight, there exist hydrothermal vents that spew boiling water mixed with minerals and chemicals. In such places, the temperature of the surrounding waters can rise above 100 degrees Celsius, a level of heat that would destroy almost every familiar animal or plant on the surface. And yet, astonishingly, life thrives there. Whole colonies of microorganisms gather around these underwater vents, not relying on sunlight for energy as most life on Earth does, but instead surviving by drawing power directly from chemical reactions. One of the most important of these reactions involves the oxidation of hydrogen sulfide, a chemical that smells of rotten eggs and is highly toxic to most surface creatures. For microbes near hydrothermal vents, however, hydrogen sulfide is not poison but nourishment, a vital fuel for their metabolism. In a world like K218b, with its abundance of hydrogen in the atmosphere and the possibility of volcanic activity releasing sulfur compounds, similar chemical reactions could be common. This makes it entirely possible that hardy microbes, not unlike Earth's extremophiles, could form the foundation of an alien ecosystem. If we allow our minds to wander further and imagine that life on this planet has managed to grow beyond the simple level of microorganisms, then the question becomes even more captivating. What might more complex creatures look like under such alien conditions? The environment of K218b is expected to consist of a deep ocean hidden beneath an enormously thick atmosphere. Such an ocean would be cloaked in near-total darkness because very little light would be able to penetrate the dense atmospheric layers and reach the water below. In such a realm, vision might not develop as the dominant sense for survival. Instead, living beings might evolve to rely on other ways of perceiving their surroundings. They might sense vibrations in the water to detect movement, use thermal signals to notice heat differences, or even respond to magnetic fields or faint chemical traces carried by the currents. On Earth's ocean floors, in places where sunlight never reaches, many creatures already navigate in similar ways. Some fish and other marine animals have developed organs that allow them to detect the faintest electrical fields, or they use chemical signals in the water to find prey or mates. It is reasonable to suppose that creatures on K218b would evolve along comparable paths. Another remarkable adaptation that could arise is bioluminescence, the ability to produce light from within the body. On Earth, this talent is found in fireflies, glowing jellyfish, and deep-sea anglerfish that use their lantern-like appendages to lure prey in the darkness. In the dim waters of K218b, glowing bodies, shimmering patterns, or pulsing flashes of light might be widespread, serving purposes of communication, attraction, or intimidation. A particularly intriguing possibility concerns the size of such organisms. In a hydrogen-rich atmosphere, physical conditions are very different from those on Earth. Hydrogen is much lighter than the mixture of gases that make up the air we breathe. Because of this, the buoyant force in a hydrogen atmosphere would be greater than in Earth's air. Buoyancy plays an important role in determining how large an animal can grow before gravity and structural limits hold it back. With greater buoyancy, creatures might be able to grow to sizes unimaginable on Earth, supported by the lighter medium around them. One could picture enormous beings with massive, slow-moving bodies, perfectly adapted to the crushing pressures of the deep ocean and the heavy blanket of atmosphere above. These creatures might resemble giant jellyfish, with translucent bodies billowing like sails as they drift through the warm waters. Others might be more amorphous, taking on shapes difficult for us to imagine, perhaps resembling floating bags or ribbons of tissue that move gracefully through the depths. Some could even rise upward into the atmosphere itself, their buoyant forms allowing them to hover and float as naturally as balloons. Whether in the ocean or in the sky, such beings would likely move slowly, conserving energy in an environment where every resource counts. Adaptation to immense pressure would be a critical factor in their evolution. The ocean of K218b could be vastly deeper than that of Earth, whereas the Mariana Trench, the deepest known point in Earth's seas, lies at about 11 kilometers below the surface. The oceans of K218b might plunge much farther. If life exists there, some of its representatives could thrive at depths between 16 kilometers and 24 kilometers, places where the pressure could rise to between 1,600 and 2,400 atmospheres. To compare, the pressure at the bottom of the Mariana Trench is already more than 1,000 times greater than the pressure at Earth's surface. On K218b, life might endure pressures even more severe, levels that would crush most materials we are familiar with. For survival in such a world, animals might evolve bodies specifically designed to withstand such crushing force. One can imagine the development of a strong yet flexible outer layer, something like a protective shell or casing that shields delicate internal organs. This outer structure might be made of dense cartilage-like material or skeletal frameworks composed of biopolymers far stronger than any found in ordinary Earth organisms. These frameworks could be several times denser and more resistant to bending or breaking than crab shells or insect exoskeletons. Instead of being fragile or brittle, the armor of such creatures might combine toughness with flexibility, ensuring that internal tissues are not damaged by sudden changes in pressure. The surfaces of their bodies could be covered with scales or plates made of biological material that balances strength and elasticity. Some might be smooth and glistening, while others might be ridged or patterned, allowing them to scatter light or communicate through subtle changes in reflection. It is possible to picture animals whose exoskeletons resemble the hard shells of crabs or lobsters, but with structures many times thicker and more efficient at resisting deformation. These adaptations would not only protect them from the weight of the water, but also perhaps serve as defense against predators or as displays in social interactions. Despite the richness of these imaginings, it is important to remember that much remains uncertain. We do not know what kinds of chemical reactions might drive the metabolism of possible life forms on K2-18b. On Earth, DNA acts as the molecule of heredity, the code that shapes every living thing. On a distant planet, there may be no DNA at all, but something completely different fulfilling the same role. Molecules unknown to us could act as the foundation for reproduction, growth, and adaptation. Yet there is one tantalizing hint that life might already exist there. Scientists using telescopes have reported the possible detection of dimethyl sulfide in the atmosphere of K2-18b. On Earth, every known source of dimethyl sulfide is biological. It is produced by certain kinds of phytoplankton and other organisms in the oceans. If dimethyl sulfide truly exists in the air of that distant world, and if it is not the result of some unknown geological or chemical process, then it would be strong evidence that biology has already taken hold. That would mean life is not only possible on K2-18b, but is already thriving, shaped and adapted to conditions unimaginably different from our own. It is awe-inspiring to consider that, even now, deep in the hidden oceans of that faraway planet, strange creatures may be moving slowly through warm waters, carrying out their lives in total ignorance of us, just as we know so little of them. For such beings, our planet Earth would be as alien, distant, and unreachable as their own world is for us. K2-18b is currently regarded as one of the most promising candidates for extraterrestrial life in the universe, though it is by no means the only one. Across the galaxy, many other planets and moons may hold similar secrets, waiting for the day when human eyes or human machines are able to look more closely. Until then, the picture of life on K2-18b remains in the realm of imagination, a canvas painted with knowledge of Earth's biology and coloured by speculation about what lies beyond. Teegarden Star B, which is also often referred to simply as Teegarden B, is one of the most fascinating discoveries in the field of astronomy and planetary science. This distant world is what scientists call an exoplanet, meaning it is a planet that does not belong to our own solar system, but instead orbits around another star far away from Earth. What makes Teegarden B particularly captivating is that it lies in what astronomers describe as the habitable zone of its parent star, Teegarden star. A habitable zone is that special distance from a star where conditions might be just right for liquid water to exist, neither too hot nor too cold, making it one of the main ingredients for life as we know it. Teegarden's star itself is classified as an M-type red dwarf, which is a kind of star smaller and dimmer than our Sun, and it is located about 12.5 light-years away from our solar system. To put this into perspective, 1 light-year is the distance that light, the fastest thing in the universe, travels in a single year, so 12.5 light-years is a staggering distance, yet in cosmic terms, Teegarden's star is still considered very close to us. When Teegarden B was first studied, it achieved something extraordinary. It was given the highest score ever recorded on what scientists call the Earth Similarity Index, often abbreviated as ESI. The Earth Similarity Index is a measure that compares other planets to Earth, with the goal of seeing how closely they might resemble our home planet in terms of size, mass, temperature, and the possibility of liquid water. A higher score on this index means a planet could be more like Earth, and therefore potentially capable of supporting life. For a time, Teegarden B held the crown as the planet most like Earth that we had ever found. However, in February of the year 2024, a new and more precise study was carried out. This updated research used refined measurements and better data to reassess the properties of Teegarden B. The result lowered its Earth Similarity Index to 0.90, which, although still very high, meant it was no longer the exoplanet with the very highest similarity to Earth. Even so, it remains one of the most promising candidates for habitability known to science. Alongside its sibling world, Teegarden Star C, this planet is among the closest possibly habitable exoplanets that we know exist beyond our solar system. The story of how Teegarden B was discovered is itself full of dedication and patience. In July of the year 2019, a large group of more than 150 scientists came together to publish their findings in the respected journal Astronomy and Astrophysics. This team was led by Matthias Seckmeister, and their work was part of a grand project known as the Carmenes Survey. The purpose of this survey was to search for exoplanets, particularly around small and faint stars like red dwarfs. Their efforts provided strong support for the existence of 2 planets orbiting Teegarden star, which became known as Teegarden B and Teegarden C. Discovering planets around stars is no simple task, especially when the star in question is faint and does not line up in a way that makes detection easy. In the case of Teegarden star, because it is not bright and because of the way its orbit and position appear from Earth, astronomers had to use a very careful method called Doppler spectroscopy, which is also known as the radial velocity method. This technique does not allow scientists to see the planet directly. Instead, it allows them to observe tiny wobbles in the movement of the star itself. A star does not remain perfectly still when it has planets orbiting it. Instead, the gravitational pull of the planets causes the star to shift slightly back and forth as they move around it. These small shifts, which change the speed at which the star moves toward or away from Earth, are detected as what are called Doppler shifts, named after the scientist Christian Doppler. By using a powerful spectrograph attached to a telescope, astronomers can see the changes in the wavelengths of light from the star, which reveal the presence of orbiting planets. To carry out this investigation, the team of scientists relied on a sophisticated instrument known as Carmenes, which had been mounted on the 3.5-meter telescope located at the Cala Alto Observatory in Spain. This observatory, situated high in the mountains, provides an ideal location for such delicate work, as its clear skies and high altitude minimize interference from Earth's atmosphere. The scientists observed Teegarden star over the course of 3 years, patiently gathering data night after night. Finally, 2 distinct and repeating signals emerged from the measurements. One of these signals had a period of just under 5 days, specifically 4.91 days, which corresponded to Teegarden B. The other had a longer period of about 11.41 days, which matched Teegarden C. These repeating cycles in the radial velocity data confirmed that there were indeed planets tugging gently on Teegarden star as they completed their orbits. Teegarden B is the innermost of these 2 planets, meaning it is the one that lies closer to its star. Its orbital period is extremely short compared to planets in our own solar system. While Earth takes 365 days to circle the Sun, Teegarden B completes an entire orbit around its star in less than 5 days. That means a year on Teegarden B is less than a week long by Earth standards. The minimum mass of this planet has been measured at about 1.05 times the mass of Earth. This value could represent its true mass if the orbit happens to be aligned in such a way that we are viewing it edge-on from Earth. Because the size and density appear similar to Earth, scientists believe it is most likely a rocky planet, meaning it has a solid surface rather than being a gas giant like Jupiter or Saturn. One of the most exciting aspects of Teegarden B is that researchers estimate it has about a 60% chance of having liquid water somewhere on its surface. However, the chances of it having a stable and lasting atmosphere are much lower, estimated at only about 3%. Without an atmosphere, liquid water would quickly evaporate or freeze away, so whether Teegarden B can truly host life remains a mystery. The parent star, Teegarden star, has its own intriguing characteristics. It is a red dwarf, which means it is a low-mass star that burns relatively cool compared to our Sun. In fact, it has only about 9% of the mass of the Sun. Its surface temperature is also far lower, around 2,900 Kelvin, which is equivalent to roughly 2,630 degrees Celsius, or about 4,760 degrees Fahrenheit. Because it is so dim and cool, Teegarden star was not discovered until quite recently. It was only identified in the year 2003, despite being one of the closest stars to our solar system. The reason it went unnoticed for so long is because it shines very faintly in visible light. Its apparent magnitude, which measures brightness as seen from Earth, is only about 15.1, and its absolute magnitude, which measures brightness as if the star were observed from a standard distance, is about 17.22. These numbers make it clear that Teegarden star is much fainter than the Sun, which has an apparent magnitude of negative 26.7. Like most red dwarfs and also like brown dwarfs, Teegarden star emits most of its energy in the infrared part of the spectrum rather than in visible light. This makes it much harder to detect with ordinary telescopes that rely mainly on visible light. Another fascinating fact about Teegarden star is its age. While our Sun is estimated to be about 4.5 billion years old, Teegarden star is believed to be at least 8 billion years old. That makes it nearly twice as old as the Sun, and it has therefore existed for much of the history of our galaxy. The sheer age of this star raises tantalizing questions. If planets have been orbiting it for billions of years, then the conditions for life might have been present for far longer than life has even existed on Earth. It opens the door to speculation about whether simple life could have arisen on planets like Teegarden B long before Earth itself even cooled from its fiery beginnings. The placement of Teegarden B within the habitable zone of its star is the most important factor in the excitement it has generated. The habitable zone is the region around a star where temperatures are such that liquid water can exist on the surface of a planet, provided the planet has the right kind of atmosphere. If a planet is too close to its star, water would boil away, while if it is too far, water would freeze solid. Teegarden B lies in that delicate balance, neither too near nor too distant. This gives astronomers hope that under the right circumstances, it might support conditions favourable to life. While we cannot yet say for certain whether this small rocky world has an atmosphere, whether it has oceans, or whether anything ever lived there, the fact that it sits in the habitable zone makes it one of the most intriguing exoplanets discovered so far. J1407. B is a truly fascinating object in space. It is not a star in its own right, but something smaller and stranger. Astronomers believe it is either a free-floating planet wandering through the galaxy without being bound to any star, or it could be a brown dwarf, which is often described as a failed star because it is too large to be a planet yet too small to shine like a normal star. What makes J1407b especially remarkable is that it is surrounded by an enormous disk made of rings, something far bigger than anything we see around the planets in our own solar system. This unusual object first drew attention in the year 2007 when automated telescopes picked up a very unusual signal. For 56 days straight, the star known as V1400 Centauri appeared to dim in a complex pattern. At first, nobody realized what was happening, but years later, in 2010, a careful review of telescope data revealed that this dimming was caused by the giant ring system of J1407b passing in front of the star. The discovery was made by Mark Pekor, a graduate student at the time, along with his advisor Eric Mamajek. Their findings were later announced in a scientific paper in the year 2012. The disk of J1407b is unbelievably huge. Its radius stretches out to around 90 million kilometers, which is about 56 million miles. To give a sense of scale, this is hundreds of times larger than Saturn's rings. The structure is not just one solid band of dust, but a complex system of multiple rings with gaps between them. These gaps may have been carved out by moons that are forming inside the disk, in much the same way that Saturn's small shepherd moons shape its rings. At first, astronomers thought J1407b was orbiting the star V1400 Centauri. However, more recent studies suggest that it might actually be an unbound wanderer that just happened to pass in front of the star, giving us a rare chance to witness its rings in action. There was even a possible observation of the object using advanced imaging in the year 2017, which suggested that it might be less than 6 times the mass of Jupiter. Between the 7th of April and the 4th of June in the year 2007, 2 large sky surveys, the Super Wide Angle Search for Planets, also known as Super WASP, and the All-Sky Automated Survey, or ASSUS, both recorded the strange dimming events from V1400 Centauri. The light curve, which is a graph showing the brightness of the star over time, revealed at least 5 major dimming episodes. The deepest one lasted for around 14 days and blocked out more than 95% of the star's light, making it appear more than 3 magnitudes fainter. On either side of this deep eclipse were 2 pairs of shorter eclipses that happened 12 days and 26 days before and after the central event. These shorter eclipses were still dramatic, cutting off at least 60% of the star's light. Despite the dramatic nature of these events, they were overlooked at the time. It was not until the 3rd of December in the year 2010 that Mark Pekor uncovered them while examining public data from the SuperWASP database. Pekor and Mamajek had originally been studying young stars in a nearby stellar association called Scorpius Centaurus. Their primary aim was to check for brightness changes in small stars, but instead they stumbled upon one of the most intriguing planetary disk systems ever seen. The discovery was first presented at the 219th meeting of the American Astronomical Society in Austin, Texas, in January of the year 2012, and a few months later it was formally published in the Astronomical Journal. Searches for any companions to the star V 1400 Centauri found no evidence of a stellar partner, which meant the object that caused the eclipses had to be something with a mass below 80 times that of Jupiter. That narrowed the possibilities down to either a brown dwarf or a planetary-sized object. At first, the team thought it might be orbiting V 1400 Centauri like an exoplanet or a binary companion, but follow-up work suggested this was less likely, making the idea of a wandering world even stronger. The object received the name J1407b in a paper published in the year 2014 by Tim van Werkhoven, Matthew Kenworthy, and Eric Mamajek. The name followed the usual convention for exoplanets, adding a lowercase b to the catalogue name of the host star. At the time, the star was often referred to simply as J1407, a shortened form of its long catalogue designation 1SWASP J1474793394394, 42.6, which encodes its precise location in the sky. The disk of J1407b is believed to be circumplanetary, meaning it surrounds the object in the same way that Saturn's rings surround Saturn, only on a far greater scale. Calculations based on the dimming events show that the disk and its host object were moving at about 35 kilometers per second, which is around 22 miles per second relative to the star. This corresponds to the disk extending outward to a distance of about 0.6 astronomical units from the center. In other words, around 90 million kilometers. For comparison, that is between the orbital distances of Mercury and Venus from the Sun. Popular media quickly nicknamed the system a super Saturn, or even a Saturn on steroids, since its rings dwarf anything we have in our solar system. The radius of this ring system is far beyond the Roche limit, the distance at which tidal forces would normally rip material apart. In this case, the Roche limit is only about 150,000 kilometers from the object, while the rings extend hundreds of times farther. This means there is room for exomoons, or if J1407b is a brown dwarf, even small exoplanets, to form within the disk. Indeed, the gaps seen in the rings strongly suggest that this process is already underway. The disk itself is tilted by around 13 degrees relative to our line of sight, which explains why the dimming pattern of the star appeared so symmetrical, but with slightly uneven durations for the entry and exit of the eclipse. Astronomers also studied how much the brightness of the star varied during the eclipse, and used that to estimate the thickness of the disk. They concluded that the disk's vertical thickness is around 130,000 kilometers. The depth of the different dimming events also revealed that the disk is made up of many separate rings with varying degrees of opacity. A detailed study in the year 2015 by Matthew Kenworthy and Eric Mamajek showed that there are at least 37 distinct rings, stretching from about 30 million kilometers to 90 million kilometers. The innermost ring is particularly dense and blocks out a large amount of light. If the density of the rings is proportional to their opacity, then the total mass of the disk could be around 100 times the mass of our Moon, which is roughly equal to a little more than the mass of the Earth. The disk even contains very specific gaps that hint at the presence of exomoons. One of these gaps is around 4 million kilometers wide and lies between 59 and 63 million kilometers from the center. This empty region seems to have been carved out by an exomoon close in size to Earth, orbiting there and sweeping material away. Another smaller gap, about 1 million kilometers wide, lies a bit closer in, between 53 and 54 million kilometers, and is also likely the work of another exomoon. Astronomers considered other explanations, such as resonances between multiple moons, but these could not explain the exact shapes of the gaps. Altogether, the evidence points to a system where moons are actively forming, just as the planets of our solar system once formed in the disk of gas and dust around the young sun. Over time, perhaps within a few billion years, this massive disk could transform into a system of fully formed moons orbiting J1407b. If the central object is a brown dwarf, then the moons might even be considered planets in their own right. Mamajek's research team first thought that the idea of J1407b being a companion bound to the star V1400 Centauri was quite believable. Their reasoning was that this star is still very young, and young stars are often surrounded by disks of dust and gas known as protoplanetary disks. Such disks can give birth to planets or orbit around both a star and a companion object. In fact, astronomers already know of other binary star systems where one of the stars is wrapped in a disk of material. A famous example of this is the star Epsilon Aurigae, which shows long-lasting eclipses because of a huge dark disk surrounding one of its components. Even though astronomers today see the idea as less likely, the possibility that J1407b was a planet-like body orbiting V1400 Centauri became very popular after the astronomers Eric Mamajek and Matthew Kenworthy announced their findings in the year 2015. They released their results through their universities, which brought the story into the spotlight. Assuming that J1407b really is in orbit around V1400 Centauri, then its speed across the sky during the year 2007 eclipse, about 35 kilometers per second, which is around 22 miles per second, would match its orbital speed around the star. That kind of speed can create very different orbital periods depending on the shape of the orbit. If the orbit is close to a perfect circle, then J1407b would circle the star in about 200 days. But if the orbit is stretched out and more oval-shaped, then the planet would take several years to make one full journey around its star. Astronomers kept watching V1400 Centauri carefully after the year 2007 eclipse, hoping to see another dimming of its light. None was found, which ruled out the idea that J1407b could have been moving in a short, nearly circular orbit. Researchers also looked back at old records of the star's brightness from as far back as the year 1890 all the way through to the year 1990. Again, there were no signs of any eclipses. This meant that about 90% of all possible orbits with periods between 10 and 20 years could be ruled out. The only remaining possibility was that the planet-like body might have an orbital period longer than 25 years. But such a long orbit would require J1407b to move on an extremely stretched-out eccentric path, which would cause serious problems for the stability of its giant disk. Taken together, the evidence pointed to a most likely orbital period between 14 and 17 years, with the strongest estimate being around 16.5 to 17 years. To fit with this idea, J1407b's orbit would need to have a high eccentricity, somewhere between 0.72 and 0.78, meaning the orbit would be very stretched out and uneven. In the year 2016, two astronomers, Stephen Reeder and Matthew Kenworthy, took a closer look at how such an eccentric orbit would affect J1407b's enormous disk. They found that the disk either filled most of the object's Hill radius, which is the region of space where the object's gravity dominates, or it even stretched beyond it. This was true no matter what the object's mass was. That meant the disk was at great risk of being disturbed by the strong gravity of V1400 Centauri whenever J1407b came closest to the star in its orbit. To solve this puzzle, they suggested that J1407b must not be a normal planet at all, but a brown dwarf with a mass of at least 20 times that of Jupiter. They also proposed that the disk must orbit around J1407b in the opposite direction of its own orbit around the star, a motion called retrograde. Such a backward-moving disk could survive longer against the pull of the star's gravity, although even then it would slowly shrink over a timescale of about 10,000 years. They further suggested that dust-producing events, like the tidal tearing apart of comets that wander too close to J1407b, could keep replenishing the disk, making it last longer. A later study in the year 2018 suggested that a lower mass between 5 and 20 Jupiter masses might still be consistent with what astronomers had observed. Yet even the retrograde disk theory left some major problems unsolved. One of the puzzles was why the disk seemed to be flat and tilted compared to J1407b's supposed orbit around the star. Normally, the gravity of the star would twist and pull the disk into alignment with the orbit, leading to a warped and unstable shape. Furthermore, no one could clearly explain how such a retrograde disk could form in the first place. If J1407b had been born as a companion to V1400 Centauri, then its disk should naturally spin in the same direction as its orbit, not in the opposite one. One idea put forward to explain J1407b's unusual eccentric orbit is that there might be yet another hidden companion orbiting even farther out from the star. This invisible partner could be disturbing J1407b's path through its gravitational pull. However, Mamajek's team had already carried out searches between the years 2012 and 2013 using different telescopes, and they did not find anything. High-resolution images taken in near-infrared light showed no sign of J1407b or any other companions of similar mass within a few astronomical units of the star. observations using Doppler spectroscopy, which measures how a star's light shifts as unseen companions tug on it, also showed no evidence of any objects larger than about 12 Jupiter masses orbiting nearby. On top of that, astronomers kept watch on V1400 Centauri's brightness for 19 years, from the year 2001 to the year 2020, and never saw any other eclipse-like events caused by objects of Jupiter's size. Altogether, the absence of recurring eclipses, the failure to detect nearby companions, and the difficulties in explaining J1407b's orbit and disk all point to the idea that it does not actually orbit V1400 Centauri at all. Instead, it may be a lonely, free-floating body drifting through space on its own. Back in the year 2015, Mamajek and Kenworthy had originally dismissed the idea of J1407b being free-floating, thinking it was extremely unlikely. Their reasoning was that the distances between stars and such wandering objects are enormous, often on the scale of 1,000 astronomical units or more. The chance of two unconnected objects lining up perfectly with Earth's line of sight so that one would eclipse the other seemed unbelievably small. They also argued that the presence of such a massive disk around J1407b suggested the object was very young, much younger than the stars in the region where it was found, which made its origin difficult to explain. But as they dug deeper into the problems of the companion hypothesis, they began to change their minds. The more evidence they gathered, the more it seemed possible that J1407b might not be bound to any star at all, but might instead be wandering freely through the galaxy with its enormous mysterious disk trailing along with it. In the year 2017, the astronomer Matthew Kenworthy and his team carried out a careful search for the mysterious object J1407b. To do this, they used one of the most powerful instruments on Earth for studying the skies, the Atacama Large Millimeter Array, often called ALMA. This vast telescope, made up of dozens of linked radio dishes spread across the dry Chilean desert, is so sensitive that it can detect the faint heat, or thermal radiation, coming from cold and distant objects, even if they are surrounded by rings of dust and gas. ALMA works by observing light not in the visible spectrum that our eyes can see, but in the millimeter radio range, which is especially good for picking up signals from chilly, faraway worlds. When the team examined the extremely sharp radio images taken by ALMA, they found something surprising. The telescope showed no trace of any orbiting companion close to the star V1400 Centauri. In fact, there was no evidence of a bound object within 100 milliseconds, which is an incredibly tiny angle on the sky. But then ALMA did reveal something else. A faint source located at an angular distance of 438 milliseconds, with a small error margin of about 8 milliseconds from the star's recorded position. At the distance where V1400 Centauri lies from Earth, that small angular separation translates into a projected distance of about 61 astronomical units. To put this into perspective, 1 astronomical unit is the average distance between Earth and the Sun, so the separation here is 61 times greater than that. This distance, however, was far too large to agree with the predicted orbit of J1407b, which had been thought to circle the star at a much closer range. Yet there was another intriguing possibility. The measured separation was only slightly different from what scientists would expect if J1407b were not bound to the star at all, but instead drifting freely through space. Calculations suggested that an unbound object moving at J1407b's estimated sideways, or transverse, speed between the years 2007 and 2017 would have appeared at about 543 milliseconds, give or take 82. The ALMA detection was close enough to that number to raise the idea that this could indeed be J1407b, seen not as a planet locked in orbit but as a free-floating wanderer. If this were the case, then the object would be moving at a proper motion of about 43 milliseconds every year. Even more compelling was the brightness of the faint ALMA source. The thermal emission matched what astronomers would expect from a substellar body, something smaller than a star but larger than a giant planet, that was surrounded by a warm disk of tiny dust grains, each no bigger than sub-millimeter sizes. This detail seemed to fit perfectly with the earlier idea that J1407b might be shrouded in an immense and complex ring system. 2 years later, in the year 2019, Kenworthy and his colleagues tried to follow up on this discovery. This time they turned to another extraordinary instrument, the Very Large Telescope, located in the high desert of Chile. Unlike ALMA, which observes radio waves, the Very Large Telescope can capture incredibly sharp images in near-infrared light, which is useful for spotting young, glowing planets and faint companions around stars. The team aimed the telescope at the position of the mysterious ALMA object, hoping to catch sight of it again. But in these new near-infrared images, the object did not appear. There was no sign of it, and the images also showed no evidence of any substellar bodies more massive than about 6 times the weight of Jupiter, beyond 30 astronomical units, roughly a quarter of an arcsecond on the sky. Likewise, there were no objects heavier than 4 Jupiter masses, beyond 100 astronomical units, or about 7/10 of an arcsecond. Because the object failed to show up in the near-infrared search, astronomers concluded that its mass must lie below the detection limit. This meant it had to be lighter than about 6 Jupiter masses, which would place it well under the 13 Jupiter mass threshold that defines brown dwarfs. In other words, if the ALMA object truly exists, then it is not a brown dwarf but something smaller, perhaps a sub-brown dwarf or a rogue planet. One idea was that it could even be a young planet that had been thrown out of its original star system. However, if it were really J1407b, then its sideways motion suggested it probably did not come from the nearby Scorpius-Centaurus stellar association, the large group of stars where V1400 Centauri itself belongs. All of this left astronomers with an intriguing but frustrating puzzle. The properties of the ALMA object seemed to match what one might expect from J1407b, but the fact that it had only ever been seen once made the case very uncertain. Without a second detection, no one could be sure whether the faint spot of light was truly moving in the right direction and at the correct speed. There were other, less exciting possibilities too. Perhaps the object was not a planet at all, but just a distant faint galaxy in the background that happened to be visible in the ALMA image. Or perhaps it was not real at all, but only a false signal created by image noise. Both of these scenarios were judged to be unlikely, but they could not be completely ruled out. To try to finally settle the mystery, ALMA once again turned its great radio eyes on V1400 Centauri during the months of June and July in the year 2024. The data from those observations is now being carefully analysed. Once the results are published, they may at last reveal whether the faint object seen in 2017 was indeed J1407b, a wandering substellar body with a grand disk of rings, or something else entirely. Gliese 504b, which is also sometimes referred to as 59 Virginias b, is an extraordinary world that scientists debate whether to call a giant planet similar to Jupiter or a brown dwarf, which is a kind of failed star that never grew hot enough in its core to shine like the sun. This object circles around a star named 59 Virginias, which is also catalogued as Gliese 504. The host star itself is considered a solar analogue, which means it shares many similarities with our own Sun, making the discovery of its companion even more fascinating. What makes this world special is not only what it is, but also how it was found. Unlike many other exoplanets that are discovered through indirect techniques such as measuring wobbles in starlight or dips in brightness, when a planet passes in front of its star, Gliese 504b was discovered by direct imaging. In other words, astronomers were able to capture actual pictures of this object using powerful telescopes on Earth. The instrument that made this possible was called HIKIAO, which stands for High Contrast Instrument for the Subaru Next Generation Adaptive Optics. It was paired with the AO188 adaptive optics system mounted on the Subaru telescope, a giant observatory with a mirror measuring 8.2 meters across. This telescope is located at the famous Mauna Kea Observatory in Hawaii, which sits high above the clouds on the peak of a dormant volcano, giving astronomers some of the clearest skies on Earth to peer into the cosmos. The discovery was credited to a team led by Kuzuhara and colleagues, who worked tirelessly to push the boundaries of what was possible with imaging technology. The first discovery images were collected in the year 2011. These images were carefully analysed, and the following year, in 2012, scientists confirmed what is called common proper motion. This means that Gliese 504b and its parent star move together through space, proving that the object is truly bound to the star and not just a distant background source. This crucial confirmation was part of a larger effort known as the Strategic Explorations of Exoplanets and Disks with Subaru Survey, more commonly shortened to SEEDS. The purpose of the SEEDS survey was to identify and study massive planets and the dusty disks of material that surround stars. By doing so, scientists hope to better understand how planetary systems form and evolve. In February of the year 2013, Kuzuhara and his collaborators submitted their official discovery paper to the journal known as the Astrophysical Journal. After months of peer review and revisions, the paper was finally published in September of that same year, marking the official recognition of Gliese 504b's existence. Not long after, in October of 2013, another study appeared in the Astrophysical Journal. This follow-up investigation brought another groundbreaking revelation. It detected methane in the infrared H-band of Gliese 504b's atmosphere. This was the very first time astronomers had managed to directly confirm methane absorption in a planet that had formed within a disk. The discovery of methane was a milestone because it revealed clues about the planet's chemical makeup and the processes happening in its atmosphere. Years later, in January of the year 2025, another leap forward occurred. A team led by Malin and colleagues used the mid-infrared instrument aboard the James Webb Space Telescope to detect ammonia in Gliese 504b's atmosphere. This was a major achievement because ammonia is an important chemical marker that provides valuable hints about the temperature, pressure, and processes in the atmosphere of giant planets and brown dwarfs. With the unmatched sensitivity of the James Webb Space Telescope, astronomers were able to see details that no ground-based telescope could ever reveal. When scientists first tried to categorize Gliese 504b, they expected it to belong to a spectral type, either in the late T class or the early Y class. These classes are reserved for some of the coldest brown dwarfs and giant planets known, far cooler than stars. Later, follow-up research suggested that the best match for Gliese 504b was the T8 spectral type. This means it is among the coldest directly imaged planetary mass objects, with an effective temperature measured at about 512 Kelvin, which translates to about 239 degrees Celsius, with only a margin of 10 degrees. That makes Gliese 504 but much cooler than most exoplanets that have been directly imaged so far, since earlier examples tended to be blazing hot young giants. Despite being cooler, Gliese 504b is physically a little larger than Jupiter, about 8% bigger. The separation between this planet and its parent star is also remarkable. It lies about 2.5 arc-seconds away in the sky, which corresponds to a projected distance of about 44.7 astronomical units. For comparison, 1 astronomical unit is the distance between the Earth and the Sun, and Jupiter lies at just over 5 astronomical units from the Sun. This means Gliese 504b sits nearly 9 times farther from its star than Jupiter does from ours. This wide separation is puzzling because it challenges existing theories of how giant planets form. The two main models, core accretion, where dust and gas gradually come together into a planet, and disk instability, where regions of the disk collapse rapidly under their own gravity, both struggle to explain how such a massive metal-rich object could have formed so far away from its star. This very puzzle is what makes Gliese 504b such a prized subject for astronomers. Its closeness to Earth compared to many other directly imaged exoplanets, along with its wide separation from its star, makes it an excellent target for detailed spectroscopic studies. By analysing the light from its atmosphere in great detail, researchers can continue to unlock secrets about its composition, temperature, clouds, and overall nature. One of the most challenging aspects of studying Gliese 504b has been determining its true mass. Unlike with smaller exoplanets where transits or gravitational tugs can provide precise measurements, the mass of Gliese 504b depends heavily on the estimated age of its host star, 59 Virginis. Unfortunately, the age of the star is not well constrained. The original discovery team adopted an age estimate of about 0.16 billion years, with a margin ranging from minus 0.06 billion to plus 0.35 billion years. With that assumed age, the mass of Gliese 504b was estimated to be about 4 Jupiter masses, with a possible range between 3 and 9 Jupiter masses. However, as other astronomers continued to study 59 Virginis, different age estimates emerged, and each age estimate led to a different conclusion about the planet's mass. In the year 2015, another group of scientists suggested the star might be much older, about 4.5 billion years, with an uncertainty range of -1.5 billion to +2 billion years. If that were true, then Gliese 504b's mass would be closer to 20 to 30 Jupiter masses, which would put it firmly in the brown dwarf category rather than that of a planet. By the year 2017, yet another study proposed an intermediate age of about 2.5 billion years, with a margin of +1 billion and -0.7 billion years. That estimate placed Gliese 504b in a mass range that sits uncomfortably between the definitions of giant planet and brown dwarf. Things became even more confusing in the year 2018, when two very different possible ages were published. One estimate suggested the star could be as young as 21 million years, with an uncertainty of 2 million years, which would mean Gliese 504b has a mass of only about 1.3 Jupiter masses, plus or minus a fraction. The other estimate proposed an age of about 4 billion years, with a margin of nearly 2 billion years, which would imply a mass of 23 Jupiter masses, again nudging the object into the brown dwarf regime. In the year 2025, several intermediate ages were suggested once again, this time ranging from about 400 million years to about 1 billion years. Such ages would suggest that the mass of Gliese 504b lies somewhere between 1 and 17 Jupiter masses, which would allow it to still be classified as a planet. Even so, the question was far from settled. Measurements of ammonia in the atmosphere hinted that the object's mass was likely within the planetary range, but at the same time, its brightness in the mid-infrared region seemed to suggest an older and more massive brown dwarf-like nature. Astronomers also pointed out that the star 59 Virginis itself appears to be older than just a few million years, and that certain unusual properties that once supported the idea of a very young age could also be explained by the possibility that the star might have engulfed another planet in its past. This event could have altered its apparent characteristics, making it trickier to pin down its true age. By the middle of the year 2025, yet another detailed study proposed that the age of the system could be anywhere between 360 million years and 2.5 billion years. This enormous range once again made it impossible to pin down whether Gliese 504b should be considered a planet or a brown dwarf. Kepler-70, which is also listed in astronomical records as KX 5,807,616 and KOI 55, is a remarkable star situated at a distance of about 3,600 light-years away from Earth. To put that in another unit that astronomers often prefer, it lies at a distance of about 1,100 parsecs. This star is positioned in the northern sky within the constellation known as Cygnus, which is also called the Swan because its shape resembles the long neck and outstretched wings of that graceful bird. Kepler-70 has what astronomers call an apparent visual magnitude of about 14.87, which makes it far too faint for the human eye to see without assistance. Our eyes, even under the darkest skies far away from city lights, can only see stars up to about magnitude 6. Because of this, anyone who wishes to observe Kepler-70 directly would need to make use of a powerful telescope, one with an aperture of at least 40 centimeters, which is about 20 inches across. Only with such an instrument could the star's faint glimmer be collected and magnified enough to make it visible. Kepler-70 is not a typical star like our Sun. It belongs to a special category called a subdwarf B star, often abbreviated as SDB. These stars are unusual and rare. They represent a brief but striking stage in the life of a star that has already undergone dramatic changes. Many millions of years ago, Kepler-70 was a much larger star. In fact, it passed through the grand and bloated phase known as the red giant stage about 18.4 million years in the past. During that time, it expanded to enormous size, shining with a fiery glow and casting out much of its outer layers. After shedding this earlier identity, the star collapsed into a much smaller form and entered the current stage that we see today. At present, Kepler-70 is still a shining sphere of gas, but its inner workings are different from those of our Sun. Unlike the Sun, which fuses hydrogen atoms into helium in its central core, Kepler-70 has already burned through its hydrogen. Now it is in the process of fusing helium into heavier elements in its heart. This phase will not last forever. When the helium fuel eventually runs out, the star will no longer be able to sustain fusion in its core. At that point, it will shrink and contract even more tightly under the pull of its own gravity, ultimately becoming what astronomers call a white dwarf, a dense, faint, but still incredibly hot stellar remnant. That is the eventual destiny awaiting Kepler-70. The star is already much smaller than the Sun. Its radius is only about 0.2 times that of the Sun, meaning that it measures only about 1/5 the size of our star across its surface. Yet this is still larger than the compact size that a white dwarf will eventually possess, because white dwarfs are often similar in size to Earth itself, despite containing nearly half the mass of the Sun. The current measurements of Kepler-70 tell us that it has a radius of about 0.203 times that of the Sun, and its mass is close to about 0.496 times the mass of our star. Even though it is smaller and less massive than the Sun, its surface shines much more fiercely. Its surface temperature is about 28,000 Kelvin, which makes it nearly 6 times hotter than the surface of the Sun. For comparison, the Sun's surface is about 5,772 Kelvin. Kepler-70's temperature is equivalent to the type of massive blue-white stars astronomers call B0-type stars. Because of this extreme heat, the star shines with an intensity far greater than one might expect for its modest size. Its luminosity has been measured at about 22.9 times that of the Sun. This means that even though it is smaller, it pours out almost 23 times as much light and energy. The history of this star has drawn the attention of astronomers, not only because of its dramatic transformation from a red giant to a subdwarf, but also because of tantalizing hints that it might have once possessed planets that survived its violent past. On the 21st day of December in the year 2011, a group of astronomers led by Stefan Charpinet announced evidence for 2 extraordinary planets orbiting Kepler-70. These potential worlds were given the names Kepler-70b and Kepler-70c. They are also known in the astronomical catalogues as KOI 55b and KOI 55c. Their detection was based on data gathered by the Kepler Space Telescope, which was launched by NASA to monitor the brightness of stars and search for planets that pass in front of them. What made this discovery especially fascinating was the method of detection. Most exoplanets discovered by the Kepler telescope were identified by the transit method, in which the planet passes directly in front of its star from our point of view, creating a tiny but measurable dip in brightness. However, in the case of Kepler-70b and c, the planets were not seen through this dimming. Instead, they were suggested by the detection of reflected starlight, the faint glimmer that bounces off the planets themselves as they orbit very close to the star. The signals also hinted at the possible presence of a smaller body between the 2 candidate planets, though this additional object has not been confirmed. If these planets were real, they would have represented one of the most extreme planetary systems ever discovered. According to Stefan Charpinet, the lead author of the paper published in the journal Nature, the 2 planets had likely endured a terrifying ordeal in their past. Billions of years ago, when Kepler-70 swelled into its enormous red giant stage, these planets probably plunged deep into the extended outer layers of the star. Ordinarily, any planet caught in such an event would be completely destroyed or vaporized. Yet these 2 worlds seem to have somehow survived, stripped of their outer material but still holding together as scorched remnants. This was not the first time astronomers had seen planets orbiting a star that had already passed through its red giant stage. There are known examples of so-called pulsar planets, worlds found circling neutron stars, which are even more extreme remnants of stellar evolution. For example, the planet PSR J 1719-14. 38b orbits extremely close to its pulsar host, completing its orbit faster than any other known planet. Still, the case of Kepler-70 was unique because it involved a subdwarf star and planets that had survived direct immersion within a giant star's envelope. The origins of the proposed planets have been the subject of debate. One theory suggests that they may have started out as gas giants, perhaps similar to Jupiter or Saturn in our own solar system. Over long spans of time, their orbits decayed and drew them closer and closer to their star. When the star expanded into a red giant, it engulfed them. Their thick gaseous atmospheres could not survive such extreme conditions and were boiled away, leaving behind only their dense solid cores. These rocky and metallic remnants then continued to orbit the stripped-down subdwarf star. Another theory proposes that there may have been only a single giant planet that was engulfed. Its core survived the destructive environment inside the red giant, but under immense forces it fragmented into 2 large pieces. If this scenario were true, the two observed planets would actually be halves of one original gas giant's core. If the planets did exist, then their orbital relationship would be extraordinary. Calculations suggested that Kepler-70b and Kepler-70c were locked in what is called a 7-to-10 resonance. This means that for every 7 times one planet completed an orbit, the other completed 10. Such resonances are known in planetary systems and often act to stabilize the orbits of planets in close proximity. More astonishingly, the two planets would have approached each other more closely than any other pair of planets ever recorded, skimming past each other at distances tighter than even the innermost moons and rings in our solar system. However, the story does not end with excitement. Later investigations cast serious doubt on whether these planets existed at all. Researchers began to suspect that the signals interpreted as reflections of planetary light were actually something else. Stars like Kepler-70 do not shine with steady brightness. They pulsate. Tiny rhythmic variations ripple across their surfaces as they vibrate like a bell. Some astronomers argued that the signals seen in the data were not planetary reflections but rather the natural pulsations of the star itself, visible beyond the usual cutoff frequency expected for such stars. Additional studies strengthened this conclusion, indicating that the supposed planetary signals could indeed be fully explained by stellar pulsations. As a result, many in the astronomical community now believe that Kepler-70b and Kepler-70c were illusions, created by the complex vibrations of the star. Yet if Kepler-70b did exist, the conditions on its surface would be unimaginable. Its temperature would reach about 7,288 Kelvin, which is roughly the same surface temperature as a bright white star of type F0. For comparison, the hottest exoplanet that has been firmly confirmed is called Kelt 9b, which blazes with a temperature of about 4,600 Kelvin. That means Kepler-70b, if it were real, would be far hotter than even the most extreme planet we know today, making it a hellish place of molten rock and searing radiation. The saga of Kepler-70 reveals just how much mystery still surrounds the lives of stars and the survival of planets that orbit them. From a star that once expanded into a red giant, to possible planets that may have endured fiery destruction and lived on as bare metallic cores, to the sobering possibility that what was seen was only a trick of stellar pulsations, this system illustrates both the wonders and the uncertainties of astronomy. WASP-76b is one of the most unusual planets discovered outside our solar system, a world so extreme and exotic that it feels more like something from a vivid work of science fiction than from the reality of astronomy. This strange planet belongs to a class of objects that astronomers call hot Jupiters, giant planets that are similar in mass and size to Jupiter, the largest planet of our solar system, but which orbit their stars at distances so close that their day sides are scorched with temperatures that metals can melt in. Unlike Jupiter, which takes almost 12 Earth years to travel once around the Sun, a hot Jupiter circles its parent star in only a few days, and in the case of WASP-76b, it does so in less than 2 full Earth days. The planet is found in the constellation Pisces, the constellation that ancient stargazers imagined as 2 fish swimming across the night sky. To Earthbound observers, the host star of this strange planet is known as WASP-76, and orbiting so close to it is WASP-76b, circling at a distance of only about 0.033 astronomical units. To put that into clearer terms, this means it is only around 4.9 million kilometers, or roughly 3.1 million miles from its star. That is unimaginably close compared to Earth, which orbits the Sun at a comfortable distance of about 150 million kilometers. In fact, WASP-76b is nearly 30 times closer to its star than Earth is to the Sun. This incredibly tight orbit explains why the planet completes a full revolution in just about 1.8 Earth days. If someone could somehow stand on the surface of WASP-76b, though survival would be impossible, the Sun in its sky would never seem to move, because the planet is tidally locked. That means one side always faces its star and is permanently scorched, while the other side is cast into eternal night. In terms of mass, WASP-76b is close to Jupiter, weighing in at about 0.92 times the mass of our solar system's giant. But despite being similar in mass, the temperature differences make them worlds apart in every sense. While Jupiter's clouds are frigid, filled with ammonia and methane, WASP-76b's skies blaze with a heat so intense that ordinary materials would be instantly destroyed. The equilibrium temperature, which is the balance temperature estimated from the heat received from the star, is thought to be around 2190 Kelvin. When converted, that is about 1920 degrees Celsius, or 3480 degrees Fahrenheit. Yet this is only the average balance temperature. Measurements of the planet's actual day side show that the heat is even greater, reaching levels where metals that are solid on Earth would exist as vapor. The story of WASP-76b began when astronomers detected it on October 21st in the year 2013. Using careful measurements from ground-based telescopes, they confirmed its existence through the transit method, where the planet passes in front of its star and causes the star's light to dip ever so slightly. From that moment forward, WASP-76b became one of the most fascinating exoplanets studied in the years that followed. By the year 2022, it remained the only known planet in the WASP-76 system, making it a lonely giant circling its blazing sun with no detected planetary companions. Soon after discovery, astronomers turned powerful instruments such as the Hubble Space Telescope and the Spitzer Space Telescope toward WASP-76b to see if they could pierce the secrets of its atmosphere. What they found was remarkable. The spectra, which are the fingerprints of light passing through the planet's atmosphere, revealed the signs of exotic chemicals. Titanium oxide, a compound rarely seen in ordinary planetary conditions, was found in trace amounts. There was also a faint but important signature of water, though not in liquid form as on Earth, but as vapor drifting in the overheated skies. As researchers pushed for higher and higher resolution, even more exotic elements began to appear. In the spectrum were hints of ionized lithium, sodium, magnesium, calcium, manganese, potassium, and, most dramatically, iron. These findings painted a picture of a planet whose atmosphere is not calm and Earth-like, but rather a roiling, metal-rich cauldron, more akin to a furnace. In the year 2021, the Gemini North Observatory confirmed the earlier detection of calcium, strengthening the evidence that WASP-76b's skies are not only filled with gases we might expect, but are enriched with elements that are metals under ordinary Earth conditions. Then, in the following year, 2022, astronomers were surprised yet again when they detected the unmistakable spectral fingerprint of barium, one of the heaviest elements ever found in the atmosphere of an exoplanet. This discovery further demonstrated how extreme the environment must be, because elements like barium require immense energies to remain in gaseous form, rather than condensing into solids. The overall appearance of the atmosphere of WASP-76b, as interpreted from data, is described as cloudy and grey. Unlike Earth's vibrant blue skies, this planet's skies are heavy with haze, likely formed from layers of vaporized metals and exotic chemical clouds. They glow with thermal incandescence, meaning they shine faintly with their own heat, in addition to the reflected light of the star. Looking at WASP-76b would be like looking at a coal furnace that is glowing faintly red and orange, though on a much larger and more alien scale. As astronomers continued their studies, new and surprising suggestions emerged. In April of the year 2024, researchers proposed that the planet might exhibit a phenomenon known as a glory effect. On Earth, a glory is seen when sunlight interacts with water droplets in the atmosphere, producing a halo of light, often observed from airplanes flying above clouds. If the increased brightness that was measured in the eastern terminator zone of WASP-76b were indeed caused by a similar optical effect, it would mark the very first discovery of a glory-like phenomenon beyond our solar system. This idea, still awaiting full confirmation, hints at just how complex and rich the atmospheric behaviour of such worlds can be. Back in March of the year 2020, scientists had already begun to notice something especially dramatic about WASP-76b. Spectroscopic analysis revealed the presence of neutral iron drifting in the skies. Under the immense dayside temperatures of about 2,400 degrees Celsius, or 2,700 Kelvin, or around 4,400 degrees Fahrenheit, iron could vaporize into a gas. On the cooler night side, where temperatures might fall closer to 1,400 degrees Celsius, or 1,700 Kelvin, or about 2,600 degrees Fahrenheit, conditions would be cool enough for that vaporized iron to condense back into droplets. From this astonishing inference came one of the most striking mental images in the study of exoplanets: the idea that on WASP 76b it might quite literally rain molten iron. The concept of iron rain captured the imagination of the public and was reported widely, making the planet famous as a world of metallic storms. Yet, as often happens in science, further investigation complicated the picture. By May of the year 2020, the Hubble Space Telescope revealed that some of the earlier data had been affected by the light of a companion star near WASP 76. This meant that the original spectral readings were slightly distorted. With updated, cleaner data, astronomers built a new model of the atmosphere. This new version suggested that while there was certainly a cloudy atmosphere made mostly of hydrogen and helium, the evidence for neutral iron was not as strong as previously believed. The dramatic image of iron rain, though still possible, was no longer the only interpretation. Instead, it was found that the apparent signals might be due to temperature differences between various parts of the planet rather than condensation of iron. Other compounds, such as titanium and vanadium oxides, were only detected in faint upper limits, rather than strong signals. By the year 2021, the controversy over iron condensation was still not fully resolved. While the possibility of iron droplets forming in the cooler regions remained an option, researchers showed that the same data could be explained by a different mechanism, namely that the planet's atmosphere was not uniform but experienced drastic shifts in temperature from place to place. Unfortunately, the data available was insufficient to definitively choose between these competing ideas, leaving the story of iron rain an open question rather than a certainty. Computer models designed to simulate atmospheric circulation on WASP 76b suggest that the fierce winds and extreme heat might allow layers of dense clouds to form. These could be made of exotic materials like aluminum oxide, magnesium orthosilicate, or even neutral iron in vaporized form. However, despite the earlier striking headlines, the models did not strongly support the idea of massive iron condensation across the night side of the planet. Instead, they suggested a dynamic, cloudy world where different chemicals formed hazes and mists, producing a highly variable and alien climate system. Another fascinating speculation has emerged from some studies that WASP 76b might not be entirely alone. There is a possibility, still only hypothetical, that a hot evaporating exomoon could be orbiting the planet. If such a moon existed, it might shed gas and dust that could produce a toroidal or donut-shaped cloud of material around the planet. This would make the system even more complex, as the planet's own atmospheric signals would be blended with material from its potential companion. Though no moon has yet been confirmed, the idea is consistent with certain unexplained signals observed in the data. WASP 76b continues to captivate scientists and the public alike. It is a place where the familiar rules of weather, skies, and even matter itself are pushed to extremes. The idea of clouds of vaporized metals, of skies glowing with heat, of elements like barium drifting in gaseous form, and of possible glory-like halos shimmering in its atmosphere, all contribute to an image of a world that challenges our imagination. It reminds us that planets beyond our solar system can be far stranger than the worlds we know, and studying them is like opening a window into realms of physics and chemistry that Earth has never experienced. WASP 107b is a fascinating world beyond our solar system, a planet unlike anything that exists around our own sun. It is known as a super Neptune, which means that in size and nature it falls somewhere between a Neptune-like ice giant and a massive gas giant like Jupiter. This strange planet orbits a star called WASP 107, a star that shines quietly within the constellation of Virgo, the celestial figure often represented as a maiden in the night sky. The distance separating this unusual planet from our own world is about 200 light-years, which means that the light leaving WASP 107b and its star today will take 2 whole centuries to finally reach the eyes of an observer here on Earth. Its existence was first brought into human knowledge in the year 2017, when a team of astronomers led by D.R. Anderson working with the Wide-Angle Search for Planets South, usually called WASP South, announced that they had found it. This discovery quickly caught the attention of planetary scientists because the planet did not fit neatly into the categories astronomers had grown accustomed to. The story of WASP 107b becomes even stranger when one looks at where it travels around its star. The orbit it follows now is so close to the star that scientists are certain it could not have been born there. The environment near the star would have been too hostile for such a giant world to have formed in the first place. The likely explanation is that WASP 107b was originally created farther out, beyond a distance of about 1 astronomical unit from the star, which is the same distance that Earth maintains from our Sun. After its birth, gravitational interactions with another planet in the same system, the larger companion known as WASP 107c, tugged and pulled on it over time, gradually forcing WASP 107b to migrate inward, closer and closer to the star. What makes this migration even more remarkable is the orientation of its orbit. Instead of gliding gracefully along the equatorial plane of its host star, it moves in a retrograde orbit, tilted so strongly that it cuts across at an angle that is far from aligned. The measured misalignment angle is astonishing, about 118 degrees, with a possible variation ranging between 19 degrees less and 38 degrees more. This means the planet's orbital path is dramatically slanted compared with the spin of its star, a situation that reveals a chaotic and possibly violent history in the system's past. The companion planet WASP 107c is itself an object of great interest. It does not follow a neat circular path, but instead moves on a highly elongated and tilted orbit, taking about 1,088 days to complete just a single trip around the star, though the measurement could be off by around 15 or 16 days. The peculiar behaviour of both worlds suggests that they may have been caught in strong gravitational battles, reshaping the order of the system. WASP 107b's strange position today is very likely the result of those long and complex interactions. The physical nature of WASP 107b only deepens the mystery. It is classified as a super Neptune or an ice giant, yet its appearance is deceptive because it is roughly as large as Jupiter in diameter, giving it the kind of bulk and girth one might expect from a much more massive planet. However, beneath that large size lies a surprisingly small amount of material. WASP 107b possesses less than 1/10 of Jupiter's mass, making it one of the lowest density planets ever discovered by astronomers. To put it another way, its matter is spread so thinly across such a large volume that it resembles a giant balloon, puffed up far more than one would expect for a world circling a star. Other inflated planets found by astronomers usually owe their swollen atmospheres to extremely high temperatures, often well above 1,000 degrees Celsius. Yet WASP 107b defies this trend. The average temperature at the top of its atmosphere is only about 500 degrees Celsius, which translates to 932 degrees Fahrenheit. While that is indeed scorching hot compared to conditions on Earth, it is far cooler than the boiling atmospheres of similarly inflated exoplanets. This unexpected inflation, despite a relatively moderate heat, makes WASP 107b stand out as an oddball among its peers, because of its extended low-density atmosphere and because it passes directly in front of its host star from our point of view. WASP 107b presents an extraordinary opportunity for scientists to study the chemical makeup of a foreign world. Every time the planet crosses the star, starlight filters through its atmosphere, carrying with it tiny fingerprints of the gases that are present. By analysing this light through a technique known as transmission spectroscopy, researchers can identify what elements and molecules float above its surface. The host star, a moderately bright orange dwarf, is particularly well suited for these observations, making the planet a natural laboratory for the exploration of alien skies. The planet's orbit is incredibly tight, much closer to its star than Mercury is to the Sun in our own system. To put it in perspective, it lies only about 1/8 of Mercury's distance from the Sun, circling its parent in a mere 5.7 Earth days. This means a single year on WASP 107b lasts less than a week for us. One of the most remarkable breakthroughs came in the year 2018, when astronomers detected helium within the atmosphere of WASP 107b. This was the first time that helium had ever been identified in the skies of an exoplanet. The discovery was momentous because helium, being the second most abundant element in the universe, plays a major role in planetary evolution and atmospheric escape. Following this first detection, scientists used the Keck Observatory in the year 2020 to take another look. These new observations reveal that the helium signature was not confined to the planet's atmosphere during transit, but extended far beyond, even after the planet had completed its crossing. This suggested that the helium was being blown away, streaming out into space. Indeed, the powerful radiation from the parent star is constantly gnawing away at the planet's light atmosphere. Extreme ultraviolet rays strip away the gases, producing a slow but relentless loss. The escaping material does not vanish quietly, but instead forms a gigantic comet-like tail, trailing behind the planet. This tail stretches out to a length about 7 times greater than the radius of the planet itself, giving WASP 107b the appearance of a gaseous world caught in the act of being peeled away by its star. Such dramatic atmospheric escape illustrates just how fragile the balance of a close-orbiting, low-density world can be. The list of discoveries did not end there. In November of the year 2023, scientists reported that the atmosphere of WASP 107b contained clear evidence of water vapor and sulfur dioxide. These molecules are crucial in understanding the chemistry and climate of alien planets. Even more astonishing was the realization that the planet's clouds are composed of silicates, the same family of minerals that make up much of Earth's rocks and sand. Imagine, instead of fluffy water vapor clouds like those seen on Earth, WASP 107b is crowned by skies filled with drifting grains of silicate particles. Along with these exotic features, astronomers found that methane, a molecule expected in such atmospheres, was surprisingly scarce. This lack of methane, combined with the new evidence, suggested that the interior of the planet was hotter and its solid core more massive than earlier estimates had assumed. The extra heat likely comes from tidal heating, a process where the slight elongation of the planet's orbit causes it to be stretched and squeezed by the star's gravitational pull. This constant flexing generates heat deep within the world, keeping its interior warmer than models had predicted. As the years rolled forward, even more unusual details came to light. In September of the year 2024, astronomers revealed that WASP 107b displayed a curious asymmetry in its atmospheric properties. When researchers examined the planet from east to west, they found differences in the climate, the distribution of clouds, and other atmospheric structures that had not been expected for a planet of its class. Most hot gas giants tend to show more uniform conditions around their equators, but WASP 107b once again broke the rules, showing that even among alien worlds diversity is greater than anyone might have imagined. All these discoveries weave together into a vivid portrait of a planet that is at once fragile and dramatic, a super Neptune the size of Jupiter yet as light as a balloon, a world that circles its star in less than a week, tilted on a misaligned path, its atmosphere bleeding into space while forming a tail like a comet, its skies streaked with silicate clouds, its chemistry altered by tidal heating, and its interior holding secrets still to be unveiled. WASP 107b demonstrates the richness and unpredictability of the universe, reminding astronomers that each discovery is not the end of a story, but the beginning of new questions waiting to be answered. Gliese 581d is a highly debated and uncertain exoplanet candidate. It is part of the Gliese 581 star system, which lies about 20.4 light-years away from us in the constellation of Libra. When it was first announced, it was described as the third planet discovered in that system. Depending on which model of the system one follows, it could be counted as the fourth planet if only 4 planets are considered real, or the fifth if earlier, now disproven models with 5 or 6 planets were used. Over the years, many scientific studies have shown that the supposed signal of this planet was more likely the result of activity on the surface of the star itself, and not from a real orbiting world. Because of this, most astronomers believe Gliese 581d does not actually exist, though some still argue that the question is not completely settled. At first, Gliese 581d seemed incredibly exciting because it appeared to be a type of planet known as a super-Earth. It was calculated to be at least 6.98 times as massive as Earth, making it significantly heavier. Despite this, it was still seen as relatively small when compared to giant gas planets. What made it particularly special was that it was thought to orbit inside the habitable zone of its star, the region where temperatures could allow liquid water to exist on the surface. If true, this would have made it the first relatively low-mass exoplanet ever found in a star's habitable zone. Computer models of the planet's climate, assuming it existed, even suggested that it might be able to maintain surface water and conditions that could support life. The story of Gliese 581d began in the year 2007. A group of astronomers led by Stefan Udry from the Geneva Observatory made the announcement of its discovery. They had used the HARPS instrument, a very precise spectrograph attached to the European Southern Observatory's 3.6-meter telescope located in La Silla, Chile. The team employed a method called the radial velocity technique. This method looks for small wobbles in a star's movement caused by the gravitational pull of an orbiting planet. From these wobbles, scientists can estimate the minimum mass of the planet and the length of time it takes to orbit its star. Their initial calculations suggested that Gliese 581d completed an orbit around its star in 83 days. Just 2 years later, in late April of 2009, the same team reanalyzed their data and came up with new figures. They discovered that the planet actually orbited closer to its star than they had first believed. According to this updated measurement, the orbital period was about 66.8 days. This meant that the planet was still inside the habitable zone, and the chance of it supporting liquid water seemed even stronger. However, this clarity did not last. In 2010, another study pointed out that when working with radial velocity data, the measurements can sometimes produce misleading signals, a problem known as aliasing. This study said that the true orbital period of Gliese 581d was still not clear at all. In fact, they even suggested that a period of just a single day was possible. Despite this, later models of the system published between 2010 and 2013 continued to support the idea of a planet with a 67-day orbital period. By September of 2012, a new analysis by Roman Baluev tried to filter out what is called red noise in the data, which comes from irregularities in the star's own activity. His results showed that the probability of Gliese 581d being real was only about 2.2 standard deviations, which is a very low level of certainty. In other words, the evidence was weak. That same year, though, another group led by SS Vost of the United States Naval Observatory, along with R.P. Butler and Nader Hagi-Yapor, published their own research. They argued that the planet likely did exist and gave it a much higher probability of being real. They even conducted a dynamical analysis of the system, checking whether the orbits of all the planets would remain stable over long periods of time. Around the same time, another study by Makarov and colleagues also suggested that if Gliese 581d were real, the system could remain stable for billions of years. In 2014, however, another major blow was delivered to the case for the planet. A study that year concluded that Gliese 581d was not a planet at all, but rather an illusion caused by the star's own magnetic and surface activity. The researchers explained that if this activity is not properly corrected in the data, it produces a signal that looks like a planet but is actually not real. They also said that the supposed detection of another planet in the same system, known as Gliese 581g, was also false and based on the same effect. The following year, in 2015, a new paper by Guillaume Anglada Escudé and Mikko Tuomi criticized the 2014 work, arguing that the statistical method used had serious flaws. Their criticism was published alongside a rebuttal from the original team, which defended their results. Still in 2015, yet another independent study gave more support to the view that the signals came from stellar activity and not from planets. In 2016, a study by E.R. Newton and collaborators pointed out another complication. For early type M-dwarf stars like Gliese 581, the rotation period of the star can sometimes be very close to the orbital periods of planets in the habitable zone. In rare cases, like what might have happened with Gliese 581d, the planet's supposed orbit could even be half of the star's rotation period. If the star's rotation period is about 132 days, then half of it is roughly 66 days, which is almost exactly the period once claimed for the planet. This coincidence makes it extremely difficult to know whether the data is showing the existence of a real planet or simply the rotation of the star. In the year 2022, a new paper further confirmed the earlier studies that Gliese 581d was likely nothing more than a false detection caused by stellar activity. This work used an improved method of analysing how the activity of the star correlates with the radial velocity signals, and it matched the conclusions of previous studies. In 2024, a new research note suggested that the possibility of Gliese 581d still cannot be completely ruled out. The note reported a new measurement of Gliese 581's rotation period, which they found to be about 148.7 days, with an error margin of about 0.8 days. This was quite different from the earlier measurement of about 130 days with a 2-day margin of error, which had been used in the 2014 study that dismissed the planet. The new value of the star's rotation period is not a multiple of the proposed orbital period of the planet, which means the signal cannot be explained so easily as a simple result of stellar rotation. However, the researchers did not reanalyze the original radial velocity data to test this, so the question remains open and requires further research. Gliese 5. 8. 1D was once believed to circle its parent star, Gliese 581, at a distance of about 0.218 astronomical units. To put that in perspective, that is roughly 1/5 of the distance between the Earth and the Sun. Scientists, however, were not entirely sure about how stretched or eccentric its orbit was. Two main ideas were considered. In one, the orbit of the planet was nearly circular, resembling the path of Earth around the Sun. In the other, the orbit was more elongated, more like the path Mercury takes around our Sun. These two models were linked to different versions of the system itself. The 6-planet model favoured the circular orbit, while the 4-planet model favoured the eccentric one. If the 4-planet model were correct, Gliese 581d would likely be locked into a special rhythm with its star called a spin-orbit resonance. In this case, it would rotate exactly 2 times for every full journey it made around Gliese 581. This strange rhythm would make a single day on the planet about 67 Earth days long, meaning the length of time from one sunrise to the next would be nearly 2.5 Earth months. The distance of Gliese 581d from its star placed it at the very edge of what scientists call the habitable zone. This is the region around a star where conditions might allow liquid water to exist on a planet's surface. When the planet was first discovered, astronomers thought it was orbiting a little farther away, outside the habitable region. But in late April of the year 2009, the original team of discoverers revised their calculations. They determined that the planet actually orbits closer to its star, completing one journey around it in about 67 days. With this new calculation, Gliese 581d was placed inside the habitable zone, raising hopes that it might have conditions suitable for liquid water. By studying the subtle movements of the parent star, scientists were able to estimate that Gliese 581d must be at least 5.6 times heavier than Earth. Earlier measurements had suggested even larger masses. Computer simulations of the entire system, assuming that the planets orbit in the same flat plane, showed that the system would become unstable if the planets were more than about 1.5 to 2 times heavier than their minimum masses. Using these earlier values, researchers concluded that the upper limit for Gliese 581d's mass was around 13.8 times the mass of Earth. Beyond these numbers, however, its exact composition remained a mystery. Nobody could say for certain whether it was a rocky world like Earth, a water-rich planet, or something else entirely. Because Gliese 581d does not pass in front of its star when viewed from Earth, astronomers cannot directly observe its atmosphere. With today's instruments, there is no way to confirm whether the planet has an atmosphere at all. For this reason, everything scientists have suggested about its climate is based on theories, calculations, and computer models. At first, when the planet was thought to orbit farther away, it seemed far too cold for liquid water. But after the revised orbit was announced in 2009, researchers in France ran detailed climate simulations in 2011. These simulations suggested that, under the right conditions, temperatures on the planet might be warm enough for surface water, provided that there was enough atmospheric pressure. One of the researchers, Stefan Udry, even remarked that Gliese 581d could be covered by a vast and deep ocean, making it the first truly serious candidate for what is sometimes called an ocean planet. The amount of light reaching Gliese 581d from its star is only about 30% of what Earth receives from the Sun. For comparison, Mars receives about 40% of Earth's sunlight. This might lead one to think that Gliese 581d is much too cold for life, but light is not the whole story. A strong greenhouse effect can trap heat and raise surface temperatures significantly. On Earth, for example, without greenhouse gases, our average global temperature would plunge to about -18 degrees Celsius, with extreme swings ranging from 100 degrees on the daytime side to -150 degrees at night, much like the Moon. Instead, Earth's atmosphere traps heat and moderates the climate. If Gliese 581d has a thick atmosphere rich in carbon dioxide or other greenhouse gases, And if its internal geology can keep those gases balanced, similar to the way Earth's plate tectonics regulate carbon dioxide, then its surface might maintain a liquid water cycle. That could, in theory, allow it to support life. Still, some calculations made by Rory Barnes and colleagues suggested that tidal heating, which helps drive plate tectonics on some worlds, would be too weak on Gliese 581d. Unless the planet had more heat coming from radioactive decay in its interior than expected, it might not have active plate tectonics at all. The planet also appears too heavy to be made only of rock. Astronomers think it might have begun its life much farther from its star as an icy planet, and then slowly drifted inward to its current position. This idea would explain both its large mass and its potential for having a deep ocean. If Gliese 581d truly exists, it would hold a very special place in astronomical history. According to work published in the year 2007, it was the very first super-Earth identified in the habitable zone of a star beyond our solar system. That made it a landmark discovery and a symbol of the search for other Earth-like worlds. Its fame grew beyond the world of science as well. During the National Science Week celebrations in Australia, in the year 2009, Cosmos magazine launched a project called Hello from Earth. This project invited people from all over the globe to send short messages, no more than 160 characters long, which would then be transmitted toward Gliese 581d. Only messages written in English were accepted. In the end, a remarkable total of 25,880 messages were collected from 195 countries. On the 28th of August, 2009, these greetings from Earth were broadcast into space using the giant 70-metre DSS-43 radio telescope at the Canberra Deep Space Communication Complex in Tidbinbilla, Australia. Astronomers have also made another exciting find, a new planet called TOI 715b, nicknamed a super-Earth, because it's about 1.5 times bigger than our Earth. This planet is interesting not only for its size, but also because it's fairly close to us in the huge stretch of space, sitting just 137 light-years away. To put that into perspective, most planets outside our solar system, known as exoplanets, are usually hundreds or even thousands of light-years away, and space wonders like black holes or colourful clouds of gas are normally much farther, often tens of thousands of light-years from us. So finding a planet this close is like spotting a rare jewel in our space neighbourhood. Could TOI 715b be a place where life might survive? Scientists are full of curiosity about this question. They look at something called the habitable zone, which is like the Goldilocks zone around a star, not too hot, not too cold, but just right for liquid water to exist on a planet's surface. Liquid water is key because it's needed for life as we know it. However, being in this zone doesn't mean water is really there. A planet also needs the right kind of air, the proper chemical mix and other conditions to make it a safe home for life. Back in 2014, scientists came up with a stricter idea called the conservative habitable zone, to focus on the best planets that might truly support life. This zone looks at planets that get about 40 to 85% of the energy Earth gets from our Sun. Excitingly, TOI 715b sits nicely in this special zone, making it a top choice for more study. This super-Earth goes around a type of star called an M-type star, or a red dwarf, which is much smaller and cooler than our Sun, about 1/4 its size and weight. Red dwarfs are like the turtles of the star world. They live very long lives, much longer than our Sun, which is a yellow dwarf star. Our Sun is about 4.6 billion years old, but this red dwarf is even older, roughly 6.6 billion years, give or take a few hundred million. This old star is calm, with low magnetic activity, meaning it doesn't throw out strong bursts of energy, or flares, that could wipe away a planet's air. Younger red dwarfs can be quite wild, blasting their planets with strong flares that might make life hard, but this one seems to have quieted down, making a more steady setting for TOI 715b. One of the coolest things about TOI 715b is how close it goes around its star, circling it in just 19 days. Because the star is small and the planet is so near, it often passes in front of the star, making clear signals that telescopes like the James Webb Space Telescope can catch. This makes it easier for scientists to study the planet's air without having to watch it for a very long time. The James Webb Space Telescope is like a space detective, helping us peek at the gases that might float around faraway worlds, even those millions of light-years away. Right now, It's busy trying to find out if TOI 715b has an air layer. If it does, that air might be easier to spot than on a heavier, drier planet, and it could hint at whether this super-Earth is a good place for life. There's even more mystery in this star system. Scientists think there might be another planet going around in the habitable zone, though it's still just a possible find with a tricky name. If it's real, it could be about the size of Earth, making it the smallest planet in the habitable zone ever found by NASA's Transiting Exoplanet Survey Satellite, or TESS. Imagine that. A tiny, Earth-like world sharing the same space neighbourhood as TOI 715b. What makes TOI 715b even more interesting is the chance that it could be a water world, a planet fully covered by oceans or hiding huge seas under its surface. These ocean planets might not have much dry land, with water, or even other liquids like lava or ammonia, covering everything. We can't directly see liquid water on faraway planets with today's tools, but scientists look for hints like water vapour in the air, which could point to oceans below. The idea of a planet wrapped in water sparks the imagination. Could there be life swimming in those waters? Hopefully not giant sea monsters, but maybe tiny alien-like creatures. Studies suggest that ocean worlds might be common in our galaxy, so there could be countless watery planets out there waiting to be found. TOI 715b also sits in a strange area called the Small Planet Radius Gap. When scientists line up planets by size, they notice a weird gap. There are many planets smaller than Earth, and others bigger than about 1.5 to 2 times Earth's size, but very few in between. It's like a missing piece in a space puzzle. This gap tells us something about how planets grow and change. Some planets might start out bigger and then shrink over time, like a balloon slowly losing air, maybe because their star's light or winds strip away their air layers. TOI 715b, sitting right in this gap, is like a clue that could help scientists solve this puzzle. It might even show whether this gap exists around red dwarfs, or if it's more about a planet's weight than its size. Speaking of TESS, this amazing satellite launched by NASA 6 years ago has been a game-changer in the search for exoplanets. It's found thousands of planets by watching for tiny drops in a star's brightness, which can mean a planet is passing in front of it. TESS looks for smaller, Earth-like planets around bright nearby stars, making them easier to study with powerful telescopes like James Webb. Unlike the Kepler telescope that came before it, which was most famous for discovering many massive planets similar in size to Jupiter, the TESS telescope was built with a different purpose. Instead of mainly looking for giant worlds, TESS was designed to search for planets that are more like our own Earth, smaller rocky worlds that could in some cases hold the possibility of life. One of the planets it uncovered was TOI 700d, a planet about the same size as Earth. This world orbits a dim, cool star known as a red dwarf, and it lies around 100 light-years away from us. At first glance, it seems like a hopeful candidate for a place that could be familiar to us. However, the closer astronomers looked, the more they realized that the planet is likely far too hot, its surface temperatures scorching in a way that would make it difficult, if not impossible, for life as we know it to survive there. But TOI 700d is only one of many exciting finds. TESS also turned its gaze toward the AU Microscopy system, a young and lively star system still surrounded by dust and gas from its early years. There, it spotted 2 remarkable planets. One of them is about 4 times the size of Earth, a world so large that standing on its surface, if such a surface exists, would make our planet feel tiny by comparison. The other is nearly 3 times the size of Earth, another colossal neighbour circling the same youthful star. These discoveries are especially important because AU Microscopy is still in the process of growing and changing. By studying planets around stars like this, scientists are able to piece together how stars are born, how planets form around them, and how these systems slowly evolve over millions and even billions of years. Now, as TESS moves into its 7th year of watching the skies, it continues to send back discoveries that stir both wonder and curiosity. Some of the planets it has found are hot Jupiters, enormous gas giants that orbit so close to their stars that their clouds are heated to blistering temperatures. But TESS does not stop at planets alone. It has also spotted events like faraway supernovae, the brilliant deaths of stars that briefly shine brighter than entire galaxies. Each of these findings brings us one step closer to answering the grand questions that humans have asked for thousands of years. Are we alone? Could there be other worlds where life thrives? And what does our own place in this vast, unending universe truly mean? One of the most fascinating examples of why the mission of TESS matters so much is the discovery of TOI 715b. On the surface, it may seem like just another distant planet, but it represents far more than a point of light in a telescope. It invites us to imagine ourselves there, standing on an alien shore, with a faint red dwarf star glowing like an ember in the sky above. Perhaps the air would be different, the colours of the horizon strange to our eyes, but the thought itself stretches our imagination and pushes us to wonder. Could such a place one day become a new home for humankind? Could our descendants walk beneath a red sun and build lives on a world that once seemed impossibly far away? The question becomes even more powerful when we think about the long future of our own solar system. Billions of years from now, our familiar sun will no longer be the steady source of light and warmth that has nurtured Earth since the beginning. Its fuel will run out, and as its energy fades, Earth will become an unlivable place. When that day comes, if humanity has survived, we may have no choice but to look to other stars for a new beginning. Planets like TOI 715b are not only objects of study for scientists, they are sparks for our imagination and hope. They remind us that out there in the darkness, the universe is filled with endless worlds, some harsh and desolate, others perhaps rich with oceans, skies, and even life. Each discovery is a whisper from the cosmos, telling us that possibilities await us, if only we dare to seek them. Here's your extract rewritten with simpler words, keeping the meaning the same but replacing complex terms with easier ones. Among the thousands of planets found outside our solar system, one stands out as both strange and exciting. Kepler 1638. B. This faraway world belongs to a group scientists called super-Earths, planets that are bigger and heavier than Earth, but still much smaller than giant planets like Neptune or Jupiter. Kepler 16. 38b was found only recently, with its discovery announced in the year 2016. Yet in that short time it has sparked huge interest. Why? Because in many ways, it seems like a possible cousin of our own planet. Kepler 1638. B is what scientists call an exoplanet. That simply means a planet outside our solar system. Instead of going around our Sun, Kepler 1638b goes around a faraway star that is very much like the Sun. Its star belongs to a group called G-type stars. Our Sun itself is a G-type star, so when astronomers found Kepler 1638b circling such a star, their excitement grew. A G-type star shines with a golden light, not too hot like blue stars and not too cold like red ones. This kind of star is thought to be especially good for life because it gives steady warmth and energy for billions of years. The planet's weight, meaning how heavy it is about 4 1/16 times heavier than Earth. Imagine taking Earth, multiplying it by 4, and then adding just a little more. That is about the size of Kepler 1638b. Because of this, scientists place it in the group of super-Earths. These planets are interesting because they are big enough to keep thick air layers, but not so big that they turn into gas giants. Kepler 16. 38b moves around its star at a distance of 0.745 astronomical units. 1 astronomical unit, or AU, is the distance between Earth and the Sun, so Kepler 1638b is closer to its star than Earth is to the Sun, but not so close that it is burned beyond hope. The planet takes about 259 1/3 days to make one full circle around its star. In simple terms, its year is a little shorter than Earth's, less than 9 months. If you lived on Kepler 1638b, you would celebrate a birthday more often than on Earth. The discovery of Kepler 1638b was announced in 2016, but its story began earlier. The planet was found using data from NASA's Kepler Space Telescope, which was launched in 2009. Kepler had a bold mission: to stare at one part of the sky and search for tiny dips in starlight caused by planets passing in front of their stars. This method is called the transit method. Each time a planet moves across its star, it blocks a little bit of the star's light. For big planets, like Jupiter, the dip in light is easier to see. But for smaller planets, especially ones the size of Earth, the drop is tiny, sometimes less than 1%. Seeing such small changes requires very sensitive tools and years of careful watching. Kepler looked at hundreds of thousands of stars, and among them was the star Kepler 1638. After years of watching, scientists saw that this star dimmed regularly every 259 days. The pattern was steady, like clockwork, and that told them a planet was there, circling its star with accuracy. That is how Kepler-1638b joined the list of known worlds. The discovery of Kepler-1638b was not just another addition to the long list of planets. It mattered for many reasons. First, its size is interesting. Super-Earths do not exist in our solar system, yet they seem common in the galaxy. They may have rocky surfaces like Earth or thick atmospheres like mini-Neptunes. We still do not know which kind Kepler-1638b is, but the chance that it could be a rocky super-Earth makes it an exciting possibility for life. Second, the planet orbits a G-type star. That matters because most exoplanets found so far go around stars very different from the Sun, often dim red dwarfs. Red dwarfs can have planets in the right zones for life, but they often flare up, sending harmful radiation. A G-type star is calmer and steadier. That steadiness makes it more likely for life, if it exists, to survive. Third, the distance of Kepler-1638b from its star places it in what scientists call the habitable zone. This is sometimes called the Goldilocks zone. Not too hot, not too cold, but just right for liquid water. Since water is needed for life as we know it, being in the habitable zone greatly raises the chance that a planet could support living things. Now comes the question that sparks the imagination. What might it be like to stand on Kepler-1638b? We do not yet know whether it has air, oceans, or mountains. But let us picture it based on what we know. Because Kepler-1638b is heavier than Earth, its pull of gravity would be stronger. If it is about 4 times Earth's weight, then its surface gravity could be nearly twice as strong. That means if you weigh 70 kilograms on Earth, you might weigh 140 kilograms there. Walking, running, and even lifting things would be much harder. Jumping high would be almost impossible, and every step would feel like pushing through deep water. If the planet has a rocky surface and air, the sky might look familiar. Its star would shine with a golden light, much like our sun. Days would feel warm but not burning, depending on how thick the air is. Nights would show a sky filled with strange constellations, totally different from Earth's. Maybe there are huge oceans reflecting the golden star, with waves crashing against alien beaches. Or maybe it is dry and desert-like, with endless rocky plains under a blazing sun. The truth is still hidden, waiting for future telescopes to uncover. The air of Kepler-1638b, if it has any, will decide whether it can hold life. If the planet has a thick air full of gases like carbon dioxide or methane, it might suffer a runaway greenhouse effect, turning into a hot furnace like Venus. If the air is thin or missing, the planet might be empty and frozen, with wild swings in temperature between day and night. But if the air is balanced with nitrogen, oxygen, and some carbon dioxide, then liquid water could exist. Clouds could form, rain could fall, and rivers might shape the land. Life, simple or complex, could have a chance to grow. This is why astronomers are so eager to study the air of faraway planets. Telescopes like the James Webb Space Telescope, launched in 2021, are starting to look at the thin gas layers around exoplanets. Maybe one day Webb or another telescope will study Kepler-1638b and reveal its secrets. To really picture Kepler-1638b, it helps to compare it with Earth. Its weight is about 4 times Earth's. Imagine 4 Earths packed into one. That is Kepler-1638b. Its distance from its star is about 3/4 the distance between Earth and the Sun. That means it gets more sunlight than Earth, but not too much. Its year lasts about 259 days, shorter than our 365 days. Its star is a golden G-type star, very much like our Sun. Its discovery was announced in 2016, using data from the Kepler Space Telescope. Each of these details paints a picture of a planet that feels both strange and familiar. Why do planets like Kepler-1638b matter so much to us? Scientists working with the United States Space Agency, NASA, announced something that immediately caught the attention of people all over the world. They had discovered a brand new planet that might actually be able to support life. This newly found world was given the name TOI 700e. What makes it so fascinating is that it is almost the same size as our Earth. Even more important, it is located in a part of space where liquid water could exist. Since water is one of the most basic and vital ingredients for life as we understand it, this discovery was immediately seen as a big step forward in the search for other worlds that might one day serve as a home for living creatures. But here is where things get even more exciting. TOI 700e is not the only planet of interest in that neighbourhood of space. Very close to it lies another planet called TOI 700d, while Planet E orbits in what scientists call the optimistic habitable zone, a place where water and perhaps even an atmosphere could exist. Planet D moves through what experts describe as the conservative habitable zone. This means it is a bit farther away from its star and may have conditions that are harder for life to thrive in. However, scientists cannot dismiss the possibility entirely. In other words, this system may give us not just one, but two potential Earth-like planets, each with its own set of chances to host life. Both of these planets orbit a small star located about 100 light-years from Earth. Now, to everyday people, 100 light-years sounds like an impossible distance, but in the grand scale of the universe it is actually considered close by. To find these hidden worlds, NASA astronomers studied the light from the star very carefully. Each time a planet passed in front of it, the brightness of the star dipped slightly. By measuring these tiny changes in brightness, scientists were able to detect the presence of the planets orbiting around it. This marks the very first time that NASA has discovered a solar system with more than one planet that could potentially support life. Up until now, astronomers have confirmed the existence of over 5,000 exoplanets, and many more continue to be added to that growing list. Experts estimate that there may be at least 10,000 more waiting to be discovered. NASA scientists are now trying to figure out if any of these planets could actually harbour life. But they also remind us of an important point. Life on other planets might not look anything like the life forms we are familiar with here on Earth. Our only example so far is life on our own planet, and that limits our imagination. The thought of new planets that might hold life sounds thrilling, almost like the beginning of a grand science fiction adventure. But before anyone starts imagining packing their suitcases and heading off to TOI 700e, we face one enormous problem: how to actually get there. Human beings have been studying the challenge of living in space for many decades, and history shows us how difficult it truly is. Back in the year 1962, astronaut John Glenn became the very first American to orbit Earth. Even though he circled the planet only 3 times, it took him months of intense physical training and technical preparation to be ready for that mission. Today, our technology has advanced far beyond what it was in the early days of spaceflight. We can now study Mars in incredible detail. Scientists already know that Mars has water and materials that could be useful to future settlers. This has fueled bold plans to send humans there, perhaps as early as the late 2030s or the early 2040s. If everything goes well, the first human mission to Mars will be a round trip lasting around 500 days. The length of the journey depends on where Earth and Mars are in their orbits around the Sun, but even if astronauts make it there safely, life on Mars will not be simple. Months of travelling in microgravity would leave their bodies weak. Without the constant pull of Earth's gravity, bones lose density, muscles shrink, and body fluids shift upward, sometimes placing pressure on the eyes and even affecting eyesight. Once they land, adjusting to Mars' weaker gravity would be yet another hurdle before they could begin exploring. Now, if simply living on Mars, our next-door planetary neighbour, seems so hard, imagine how much more difficult it would be to reach planets that are dozens or even hundreds of light-years away. At first thought, travelling at the speed of light seems like the obvious answer, but scientists believe this is impossible with the laws of physics as we currently understand them. To give you an idea, light moves almost 1,000,000 times faster than sound. At that speed, you could reach the moon from Earth in just 1 single second. You could even travel from Los Angeles to New York in less than the blink of an eye. The problem is energy. Moving any object at that unimaginable speed would require an enormous and currently unreachable amount of energy. At present, our rockets still depend on chemical fuel that is not too different from the gasoline used in cars. This method is far from efficient for long-distance space travel. That is why scientists are now exploring new technologies such as electric propulsion, magnetic propulsion, and even a particularly promising concept called the solar sail. A solar sail is an enormous, extremely thin sheet that captures and uses the pressure of sunlight to push a spacecraft through space. Prototypes of these spacecraft already exist, and experts believe that one day they could travel at speeds of up to 10% of the speed of light. That would still be far from enough to reach planets like TOI 700e within a human lifetime, but it is a major step forward. Some scientists are even thinking outside the box, suggesting an entirely different possibility. Instead of trying to build faster spaceships, what if we use planets themselves as our travelling vessels? These would be special planets known as rogue planets, worlds that do not orbit any star but instead drift freely through the galaxy. Think of it this way. Trying to settle Mars is like moving into a house that already exists. You have to adjust to its design, its lighting, and its quirks. On the other hand, moving to a rogue planet would be like building a brand new house designed exactly to suit our needs. Rogue planets may be dark, cold, and lonely in space, but if they have underground resources such as water, they could provide stable gravity, plenty of room, and natural protection from dangerous cosmic radiation. If human technology ever becomes advanced enough, we might even learn to control these planets and generate new kinds of energy upon them. Of course, this raises another question. Where could we actually find these wandering worlds? Astronomers have already detected a number of rogue planets within the Milky Way galaxy. Some of them were probably thrown out of their original solar systems by the pull of powerful gravity, while others may have formed alone, drifting from the very beginning. The chances of one drifting into our own solar system are extremely small, but if it ever happened, it could seriously disrupt the orbits of our planets, changing the way they receive light and heat from the Sun. And if one of these rogue planets were to collide with Earth, the results would be disastrous beyond imagination. Still, discoveries like TOI 700e and TOI 700d, the identification of rogue planets wandering through our galaxy, and the search for new ways of travelling across space all remind us of something important. Our universe is vast, mysterious, and full of possibilities. Humanity's journey into the stars is only just beginning, and no one can predict what new homes or new forms of life we may one day encounter among them. Kepler 22b is a strange and mysterious exoplanet that rests in the constellation of Cygnus, the great swan in the sky. At first, hearing about it might not sound like much of a thrill. After all, scientists have already discovered thousands of planets scattered across the universe. But this particular one is extraordinary. Kepler 22b was the very first planet discovered by the Kepler Space Telescope that sits within what astronomers call the habitable zone, the special region around a star where temperatures may allow liquid water to exist. And as every scientist knows, water is the key ingredient for life as we understand it. Where there is water, there is always the chance, small or great, that life might appear. For this reason, many dreamers and thinkers believe Kepler 22b could one day serve as a second Earth for humanity. Now, finding planets like this is no easy job. Astronomers cannot simply point a telescope into the sky and expect to see them glowing there like distant lanterns. Even famous instruments such as the Hubble Space Telescope struggle with this task. The reason is simple. Most exoplanets are incredibly small and faint when compared to the dazzling light of the stars they orbit. The glow of a star can easily hide its planets, like the sun hides the light of a candle in daylight. This very problem appeared when astronomers were studying the star Kepler 22. But instead of giving up, scientists used an ingenious trick to hunt for its hidden worlds. They took photograph after photograph of the star, carefully collecting images over long stretches of time. Then they studied them with patience, asking a simple question. Do we see a tiny shadow sliding across the face of this star? If the same shadow appeared again and again, always returning in a regular rhythm, it was a strong sign that a planet was crossing in front of the star, an event astronomers call a transit. From these transits, researchers could confirm the planet was real, measure its size, learn how far away it sits from its star, and even begin asking the most important question of all. Could this world possibly support life? So, what do we actually know about Kepler 22b? Surprisingly, quite a lot. For one thing, it bears several similarities to Earth, but with some striking differences. It is about 2.5 times larger than our planet, which means it could hold vast oceans of water and offer far more space for life to grow and spread. But its gigantic size also comes with challenges. Travelling across its enormous surface would not be a quick journey. Imagine boarding an airplane and instead of arriving in a few hours, your flight would last several long days just to cross one region of this alien world. The star that Kepler-22b orbits is called Kepler-22, and it belongs to the family of yellow dwarf stars, the same type as our Sun. In many ways, it is almost a twin of our Sun, sharing nearly the same size, nearly the same radius, and even nearly the same age of around 4 billion years. The biggest difference is brightness. Kepler-22 shines about 1/5 dimmer than our Sun. Because of this, you cannot simply go outside on a clear night and expect to see it shining above you. It remains invisible to the naked eye. The planet's exact weight is still a mystery, but some scientists think it might be as much as 36 times heavier than Earth. If that is true, then the pull of its gravity would be about 6 times stronger than the gravity that holds us here at home. To picture this, imagine lifting a sack of potatoes weighing 20 pounds here on Earth. On Kepler-22b, the same sack would suddenly feel as though it weighed 120 pounds. Your own body would feel impossibly heavy, and even the simple act of standing might demand the strength of an athlete. Walking or running could feel like a battle against the very ground beneath your feet. Such a powerful gravity would shape life in unusual ways. Plants might be unable to stretch tall into the skies as they do on Earth, instead growing short, thick, and stubbornly rooted to the soil. Animals might need to be stocky and heavily built, with strong muscles and perhaps multiple legs to keep themselves from collapsing. If creatures live there, they might look nothing like the animals we know. One could imagine squat beings or spider-like monsters built for strength instead of speed. It sounds like something from a science fiction tale, but the truth is we simply do not know yet. If the gravity is only a little stronger than ours, life there might feel much more familiar. Another important fact: Kepler-22b orbits its star a little closer than Earth does to the Sun, about 15% closer. If it were placed within our solar system, it would sit neatly between Earth and Venus. Yet, this does not automatically mean it is unbearably hot. Remember, Kepler-22 is slightly cooler and dimmer than our Sun, with a surface temperature of around 10,000 degrees Fahrenheit, allowing Kepler-22b to rest comfortably in the life-friendly zone where water can remain liquid. But mysteries remain. The planet might not spin in the same balanced way as Earth. It could tilt on its side like Uranus, leading to seasons of terrifying extremes, ice-cold winters followed by blazing summers. Or worse, it might be tidally locked, forever keeping one side in burning daylight and the other in endless night. If that were the case, only a thin strip of twilight between the two sides might offer a home for life. Scientists can only hope that its rotation is more gentle and Earth-like, with day and night taking turns across its surface. Here lies perhaps the most thrilling idea: Kepler-22b may hold a vast ocean. If this turns out to be true, it could be the greatest gift of all. Oceans act as natural air conditioners for a planet. They swallow heat, spread it evenly, and keep the climate balanced. That stability gives life its best chance to grow. Billions of years ago, Earth too was tamed by water. Pools of water first formed, then grew into seas and oceans, cooled by the moon's pull. Over time, this watery cradle helped life awaken and flourish, eventually giving rise to the rich, beautiful planet we know today. Now imagine this. If Kepler-22b has water but no atmosphere, then its surface temperature would likely be around 12 degrees Fahrenheit, far too cold for humans to live without heavy protection. But if the planet has an atmosphere like Earth's, its average temperature could rise to about 72 degrees Fahrenheit, which is almost perfect. On such a world, you could spread out a blanket under an alien sky and enjoy a picnic while gazing at stars we have never seen before. One more surprise: a year on Kepler. 22b does not last the same as a year on Earth. The planet takes about 290 days to complete one journey around its star, which is just a little longer than 9 months. This means if you lived there, birthdays and holidays would arrive more often than they do on Earth. But there is something missing. Kepler-22b has no moon. Its night skies would be dark without the comforting glow of moonlight. Still, you might look up and, in the distance, see our Sun shining faintly as a tiny star, a beautiful reminder of the world we left behind. The truth is, we still know very little about this mysterious planet. We do not even know for sure what type of world it truly is. Perhaps it is rocky like Earth. Perhaps it is a gas giant with swirling clouds and crushing pressures. Or perhaps it is something even stranger, a massive water world covered entirely by a global ocean. If so, human settlers might one day build floating or underwater cities, filter its alien waters for drinking, catch strange new fish, and maybe even begin to change, becoming more amphibious once again. In a way, we might find ourselves returning to our ancient roots, back to the water where all life began. Some astronomers already think that Kepler-22b may belong to a fascinating type of planets known as mini-Neptunes. And yes, that is an actual category scientists use. It is not just a playful nickname. Mini-Neptunes are worlds that are bigger than Earth but smaller than Neptune, often wrapped in thick, mysterious atmospheres. But here's the catch. Nothing about Kepler-22b is confirmed yet. What if it is not a mini-Neptune at all, but something far more familiar, a rocky planet solid beneath your feet, just like Earth? If that is true, then the next great question arises. Does Kepler-22b have an atmosphere? And if it does, what kind of atmosphere is it? Could it be gentle, life-friendly air, rich in oxygen and nitrogen, where plants could grow and humans could breathe easily? Or could it be more like the thick, suffocating shroud of Venus, a planet where the skies rain acid, the pressure would crush a person flat, and the heat is so unbearable that metal would melt? On Venus, no human could walk freely. Its air is poisonous, its heat is merciless. If Kepler-22b resembles that kind of world, the only way for people to survive would be to dig deep underground, carving out hidden shelters far below the surface. Down there, away from the deadly sky, life might cling on. But even then, another problem would appear. Underground, there would be no sunlight, no natural warmth. We would have to invent new ways to create heat, otherwise everything would be locked in freezing cold. So you see, Kepler-22b is a planet filled with possibilities, both thrilling and terrifying. Right now, the truth is hidden. We cannot yet say whether it is a place for dreams or a place of nightmares. All we can do is wait, watch, and let scientists slowly uncover its secrets. One day, they will know for certain. Until then, it would be unwise to make grand plans about sending humans there. Imagine the embarrassment if humanity launched great spaceships full of hope, only to discover later that Kepler-22b was nothing more than a giant ball of gas with no solid ground at all. For now, the only world we know with life for certain is our own beautiful planet Earth. Whether that life always behaves with wisdom is a matter of debate. But one thing is certain, humanity never stops searching. Our curiosity stretches far beyond the sky. Astronomers have already found more than 4,000 planets outside our solar system. And here comes the most thrilling part. NASA has carefully made a special list of 24 planets that may not only resemble Earth, but might actually be even better. These special planets are called superhabitable worlds. On such worlds, the balance of air, water, temperature and sunlight could be even more perfect than what we enjoy on Earth. Imagine that. Somewhere far away, there may be planets more welcoming, more comfortable, and more perfectly suited for life than the home we know. So let us begin to explore some of these extraordinary worlds. First, we meet Koi 5715.01. The name may sound technical and strange, but don't let that fool you. This planet is no ordinary discovery. It sits in the constellation of Cygnus, also known as the Swan, a part of the night sky filled with stories and legends. Why is KOI 5715.01 so special? To answer that, let us look at its star. Our own Sun is what scientists call a yellow dwarf star. It has done an incredible job of supporting life here on Earth for billions of years, but as far as long-term habitability goes, it is not the absolute best kind of star. No offense, Sun, you are still magnificent. But there are stars out there that might actually be even better for nurturing life. KOI 5715.01 orbits an orange dwarf star. These stars are smaller than our Sun and shine with a softer, gentler glow. Their brightness, or what scientists call luminosity, is lower, but that does not mean life on their planets would be dim and gloomy. If a planet sits close enough to such a star and has a thick protective atmosphere, its skies could actually be brighter, its colours richer, and its landscapes even more vibrant than what we see here on Earth. Here is something remarkable. Our Sun will live for only about 7 to 8 billion years in total, and it has already used up more than half of that time. But orange dwarf stars can keep burning for an astonishing 45 to 70 billion years. That is many times longer than the lifetime of our Sun. And this is fantastic news, because it means planets orbiting these stars have far more time for life to appear, evolve, and flourish. Think of it this way. If we discover a planet around an orange dwarf star that is about 7 billion years old, then the odds are high that life may already be thriving there. Now, Kowai 5 715.01 is estimated to be about 5.5 billion years old. That might sound a little young, but remember, life on Earth began when our planet was younger than that. So who can say what might already be happening on that distant world? This planet lies in its star's habitable zone, the perfect distance where water could remain liquid, which is one of the key ingredients for life. A single year there lasts only 190 Earth days. Imagine celebrating New Year's twice as often. KOI 5715.01 is almost twice as large as Earth. Its average temperature is about 52 degrees Fahrenheit, which is a bit cooler than Earth's average of about 57 degrees Fahrenheit. But with stronger gravity helping its atmosphere hold onto heat more effectively, it may actually feel warmer than the numbers suggest. Of course, there is one major problem. It is unimaginably far away. This planet is about 3,000 light-years from Earth. To put that in perspective, that is roughly 18 quadrillion miles. Even with our fastest spaceships today, such a journey would take longer than the entire span of human history. But do not lose heart, because there are other fascinating candidates that are a little closer. Take KOI 3010.01, for example. This world orbits a star known as KOI 2010. It sounds like a very pleasant place indeed. The average temperature on KOI 3010.01 is about 67 degrees Fahrenheit, which is a touch warmer than Earth. But scientists think that is actually a very good thing. They believe the perfect planet for life would be about 10 degrees warmer than Earth, because that little extra warmth makes conditions more comfortable and increases the odds that life could appear and thrive. This planet has a radius about 1.5 times larger than Earth's, so it is slightly bigger but still close to Earth's size. Scientists are fairly confident that it has an atmosphere, though they are not yet certain what exactly it is made of. Still, many believe it may resemble the air we breathe here on Earth, which makes it all the more exciting as a possible home for life. There is a very good chance that this faraway planet could have oceans. Scientists even believe that water might cover as much as 60% of its surface. That is more than what we see on Earth, and in some ways, it could actually be better. You see, Earth has a lot of water, but perhaps too much of it. A truly balanced world would ideally have a more even mix of water and land, enough oceans to support life, but also plenty of solid ground where living things can spread, grow, and thrive. More land means more space to build ecosystems and more resources for life to use. But here is the detail that excites scientists the most. This planet, known as KOI 3010.01, is so similar to Earth that experts estimate there is an 84% chance that life could exist there. Now, that does not necessarily mean intelligent creatures with cities and technology. It might simply mean the presence of animals, plants, or other living forms. Still, the idea of discovering alien animals is thrilling. Can you picture what they might look like? Kepler 186f is often spoken of as one of the most promising places for life outside our own world. Astronomers like to call it Earth's cousin because in so many ways it seems to resemble our planet. But it is important to be clear, it is not an identical twin. Rather, it is more like a sister, related, recognizable, sharing many familiar traits, but still carrying its own personality and differences that make it unique. This intriguing planet circles around a kind of star called a red dwarf. Red dwarfs are the quiet workhorses of the universe. They are much smaller and dimmer than even orange dwarfs, and when compared to the Sun, they shine with only a faint glow. Yet their weakness is also their strength, because these stars burn so slowly that they can live for unfathomably long times. Some are expected to survive for trillions of years, far longer than the Sun itself. This long lifespan gives planets like Kepler 186 an extraordinary chance. The conditions for life could last not just for millions of years, but for billions or even trillions. Because this planet orbits closer to its red dwarf star than Earth does to the Sun, it does not sit in total darkness. Its skies would not look black and lifeless, but instead would likely glow in a permanent reddish hue, as though the world were bathed in the light of an endless sunset. Imagine walking outside to see the heavens forever painted in shades of crimson and copper, as if dawn and dusk had merged into one never-ending scene. Some might find this deeply romantic, a sky full of soft twilight that never ends. Others might find it unsettling, as the warmth of a bright noonday sun would never arrive. One could ask themselves, would you enjoy living in a place where the light never truly changed, where the sun never fully rose and never completely set? Kepler 186f also shares another familiar quality with Earth, its size. This planet is almost the same size as ours, which carries both advantages and disadvantages. A planet slightly larger than Earth, often called a super-Earth, would have stronger gravity. Stronger gravity helps such planets hold onto their atmospheres more tightly. That means the air would not easily escape into space, leading to a thicker, more protective atmosphere. Such an atmosphere would shield the surface from dangerous cosmic rays, trap warmth to keep the planet from freezing, and possibly even allow oxygen-rich air to accumulate. That could make the planet far more comfortable for life. The trade-off, however, is that stronger gravity would weigh everything down. Imagine waking up in the morning and feeling as if even the simplest task, like standing up or walking across the room, was slightly harder, as though your body were heavier than it ought to be. For many people, it might feel as though every day was spent climbing uphill. Yet for life that evolved there, such gravity would be completely normal. Another fascinating aspect of Kepler 186f is its axial tilt, the angle at which the planet leans as it spins. This tilt is nearly the same as Earth's, and it makes a world of difference. Because of this tilt, the planet would likely experience seasons much like ours, periods of warmth, periods of cold, and a familiar cycle of day and night. To understand how important this is, we only need to look at our neighbour, Mars. Mars too lies within the Sun's so-called habitable zone, yet because its tilt is unstable, its climate has shifted dramatically over time. Long ago, Mars may have had oceans, but those oceans vanished as the planet's climate changed. Today, it is little more than a barren, frozen desert. That lesson shows us how even a small difference in tilt can determine whether a planet thrives with life or ends up lifeless. However, there is one major problem with Kepler 186f. It is unimaginably far away from us. The planet lies about 490 light-years from Earth. To put that in perspective, 1 light-year equals nearly 6 trillion miles. That means this world is roughly 3 quadrillion miles away. With today's technology, such a journey is completely impossible. For now, it exists for us only as a dream, a faraway cousin we may never meet, unless one day humanity learns to travel between the stars. Before Kepler 186f was discovered, the title of most Earth-like planet belonged to 2 other worlds, Kepler 62e and Kepler 62f. These planets too carry a number of striking similarities to Earth. Kepler 62e is about 1.5 times larger than our planet, while Kepler 62f is only a little smaller than that. They orbit a star in the constellation of Lyra, which is about 1,200 light-years away from us. For comparison, that is more than twice the distance to Kepler 186f. On Kepler 62e, a year is quite short compared to Earth's. Instead of lasting 365 days, a full orbit there takes only about 122 days. Imagine celebrating your birthday 3 times as often as you do now. Time itself would feel very different on such a world. Scientists believe that both Kepler 62e and Kepler 62f may be water worlds. That means they could be covered almost entirely by vast oceans stretching from horizon to horizon. If they have land at all, it may be limited to scattered islands, like small jewels scattered across an endless sea.